All right. Let's see. Let's see if it works. Let's see if it works. Hi,
Yes, hi.
Athar, Minal.
Yeah,
Welcome. Minal, are you there? Hi.
yeah. Hi.
Perfect. Hi. Welcome, both of you. We are okay. Late OP, guys. The stream. Okay, never mind. Um, there's something hanging up on my OBS. I hope that it doesn't play up. How's everyone?
Yeah,
Uh,
we are great. We're great.
Awesome, awesome, awesome. Okay, so wait, let me just take out a second and just figure this out because there is a lot of problems in my YouTube studio for some reason. Wait, hang on, guys. Are you able to hear me? Chat, can you just confirm if we are audible, visible? Late OP, देख अभी भी late OP चल रहा है.
Oh,
Hmm.
wait.
मतलब it's not going
Zoom में
across.
तो सही आ रहा है. Zoom में तो सही
Yes.
आ रहा है. इधर ही
Yeah.
glitch है.
There's something wrong with the streaming part. Hello Sid. Okay. Late OP. Hello all. Hello. Okay. Should I restart? Should I restart it? I think
Yeah.
Yeah, it can. और connection तो सही है ना?
connection तो सही है. Uh, yeah. Wait. I'm just going to. I think I'll just. Uh, but then if I restart, I'm not sure if it'll work because there is this stream will end then. Mm, wait.
So, what exactly is the issue
People are
right now?
saying don't restart. It's good,
Yeah, it's
but
good.
I'm getting a lag.
Yeah,
I'm getting a lag.
because I can't see the comments. The comments are not coming up. I'm not able to see what chat is saying. So
No, chat is saying. Oh, wait. Somebody give. Okay, yeah. Chat is saying good.
it's good.
Yeah.
Yeah, I can
Okay.
see the chat at least.
Okay.
It's
Wait.
continuously refreshing.
Yeah. 1 second. 1 second. Let me just open up a new tab on my on live YouTube, and it should be all right. Okay. Okay. No restart. All fine. Don't restart. Okay. Cool. Awesome. Now I can see everyone. Okay, great. Oh, thank God. All right. Open another tab. Yes, that's what I did. Thank you, everyone. Thank you for hanging on there. Captain America, all perfect here. Lagging a little. No, it's okay. I think we are good. Are you scientists, Shreya Joshi? We are all scientists. Yes. Shubhankar Gupta, thank you for your streams. Looking forward to more stream on philosophy. Thank you, Shubhankar. Thank you so much. This is a stream that I've been waiting for since, yeah, like I said on Instagram, since I was 8 years old. I wanted to talk about the universe for so long. Is there somebody else on the chat with us? No. Okay, cool. How are you? Meenal, how are you? Atharv, how are you?
I'm good.
Yeah, we are
Wait,
great. We are great.
So let's just start by like introducing yourselves. Atharv, you go. Just tell me what you do and why are you here talking about astrophysics?
So yeah, I am Atharva Baghol. I'm a third year undergraduate student at IISER Bhopal in the Department of Physics. So yeah, I just had this knack of doing astronomy since my eighth grade,
Yeah.
and not many people have the exposure to learn it, by the way. So as we are learning it, I want to give it to all who have interest, who want to pursue it. It's
Brilliant.
just outreach, pure outreach.
Brilliant. So you have information, you want to share it. That is the whole purpose of my YouTube channel. So I'm so glad that you are here. Meenal, so you made it possible. We started talking about astrophysics, and that's
yeah.
when this whole thing came about. So thank you so much for introducing me to Athar also. Yeah, just tell me what got you here.
Well, about me, I am a student of physics and astrophysics, currently in the second year, and I'm studying at University of Sussex.
Yeah.
And I have been interested in this field since I was in third grade. So I saw the moon through the telescope for the first time, and I was like, oh my God, there is a world beyond ours. And as I got to know more about it, I went deep in that hole, and now I'm, in the black hole of
We are.
astronomy.
I, I love that. It's yeah. So I think a lot of us chat. I don't know if you felt this, but the curiosity about the universe starts really early in
Yeah.
children. There's that sense of it started for me when I read Childcraft, and I read that book in the universe. I think
Oh,
it was
yeah.
part 8 or something, and it was just insane. I loved it so much. I had a favorite planet and everything.
What was your favorite planet?
Neptune. I don't know why. It just was.
Why Neptune? Yeah,
I don't know
it's an
why.
interesting planet, but still, why?
Yeah, I don't know. Like it had all the planets had personalities for me when I was
Oh,
reading
okay.
it. Yeah, and
At least better than Pluto.
oh yeah, I'm so glad that my favorite planet wasn't Pluto. I would have been so disappointed.
Heartbroken. Yeah.
But yeah. So I had so all the planets had personalities, and Neptune seemed like a cool, like a cool person to hang out with. So
Because it's blue or something.
maybe I don't know. So yeah, that's when it started, and then yeah. So everything got me more interested. So all Star Trek, and there was a series called Lost in Space, which
Yeah.
I don't know if you guys have seen,
Whoa.
but yeah, it was super.
Yeah.
And then like all of it, like gravitational waves and black holes, and yeah, everything has fascinated me. So I am so excited to learn about it officially for the first time today.
Yeah.
Yeah,
I mean, we are still
that's great.
learning,
That's
so
great.
we are excited
We are still
too.
learning. We are not any masters in it.
We are, yeah, I think that's fair for all of us to say. I think that is completely fine. And there is this tendency to ask that, oh, you are not a master, so what are you doing teaching? But
Yeah,
I don't think that's fair. I think that we can always teach and learn at the same time. That should be acceptable. So
that is true. Yeah.
that's what we are trying to do.
Yeah.
Okay, start it off. Tell me everything. Tell me one at a time, but tell me everything.
Okay. So we're
Yeah.
gonna start by referring to your video on neuroscience of religion, and
Whoa. Okay. All right. That was long time back. In live streaming years, that was around 2 months ago, which is a long time back on YouTube. Okay. What about that?
so in the beginning of the video, you had mentioned that there are 3 questions that kind of, if we get the answers to those questions, it helps our chances of survival, right? So those 3 questions you said was what,
Hmm.
where, and why. So then you gave an example as to samne tiger hai. Now you know that's a tiger. So you have an answer to the what. You know where it is. It's right in front of you. Now the why. We don't know why it is there.
Yeah.
So if we know why it is there, if we know that it's going to eat us, then we're going to run away.
Right.
And if we know, oh, it's not harmful at all, we're just going to pet it or something. But the answer to the why actually gives us the reaction that we will give to the situation, right?
I've
And
spoken about
Yeah.
this in religion, trying to explain how there is a fundamental curiosity in every human being. This
Yeah.
need to know. When you
Exactly.
look at something, you need to know. Not knowing is a horrible situation to be in. So
Yeah.
I'm
We
Absolutely.
just don't
Absolutely.
know how to react then.
yeah, and I'm guessing that for the earliest human beings, when you look up at the sky at night, what would they have thought? What is going on there? All these blinking lights and things that keep changing with seasons. What is going on there? Why is this happening?
Yeah.
Yeah.
I think
Yeah.
the point of this stream is not really like, it's not we're going to teach, oh ye aisa hota hai, this is that.
Yeah.
It's we're going to try and explore the minds of ancient humans, try and relive how they lived, and
Yeah.
guess कि उनका reaction कैसा होगा for
Yeah.
the first time.
Yeah. That's
So
a
yeah,
good place
it's
to start.
we
And
basically
why did
learn
they
how to learn.
come to those theories explaining such things and all?
Yes.
The theories that they created on their own. in order to understand what's going on exactly.
Yes. So throughout history, everybody had a theory. That's the wonderful thing about human beings. Nobody has ever not
Yes,
known.
every civilization had its own theory.
Every civilization at every time scale had its own theory. So nobody says, "ये क्या है मुझे नहीं पता." Everybody had an explanation. Their explanation kept changing.
Why?
It's like the sky. We had the same sky. There were so many different explanations to just one thing.
Wow.
And it's so fascinating just to
Until the explanation became common when
Yeah.
physics was introduced in that.
So there are a lot of people who would argue with that because it's still not as common as we would like it to be. But I love that line though. We are all under the same sky, but we all have a different explanation for it. Wow, what a line, yeah.
Yeah,
Too
absolutely.
good. Too good.
What a
What a
line.
line.
proud of myself.
Yes, can we have Meenal merch for that one? I love that line. Okay.
Okay.
Tell me, how did it start? How do you want to tell me about this?
Yeah,
All right.
Yeah.
so we want to explore many what you call civilizations on its own. So as we are in India, without loss of generality, let's start with Indian civilization and how it went about.
Sure. Okay.
Yeah, so first thing I would like to point out that there were two main things in the Indian civilization. What was done? That was Mahabharata war and the Vedas and Upanishads. So I'm not a I don't have a deep study in this, but just the facts, those were available from the internet.
Yeah.
And those passed on for our grandparents after all.
Yeah.
In the story form, bedtime stories and everything.
Yeah.
So this interesting concept of Kali Yuga, which the Mahabharata war and Vedas states, it actually if we plan to refer to the Kali Yuga, then we would say that its coordinates of the Kali Yuga in time scale were in that time when two eclipses were 13 days apart. So that is our Kali Yuga start. That's when our Kali Yuga started.
Wait, did that already start?
If we referred it to the obviously it started after Krishna's. I don't remember that
when
entirely,
Krishna died. Okay.
Then the Kali Yuga started.
Okay, so how is this connected to astrophysics?
So this is connected to astronomy as we try to make astronomy a type of a calendar. So basically, two eclipses 13 days apart is a calendar. Right. Of course. So those solar eclipse and a lunar eclipse, that was that time. So I guess Grahan, that's what they call it.
That was the word. Yes.
Yeah. Sanskrit word.
The idea of
and
time itself. Tell me.
Yes. Go ahead.
Okay.
Go ahead.
No, the
idea of time.
The idea of time itself is linked to astronomy. So we can't really detach time from astronomy because for a long time those were the same. Our idea of time was the idea of our knowledge of stars.
Astronomy. Yes. Right. Yes, absolutely.
Okay.
Yeah, so we also find this in the Udyoga Parva and Bhishma Parva in some ways and other related to the Mahabharata war. In other things, there are Vedas and temples, so it's related to the Vedas. One specific Veda where we find astronomy in a sense of like stars and time or the orientations.
Athar, 1 second. There is some sound issue. Your audio is coming in left-sided. All right, hold on. Is Athar voice okay? Can you confirm? Athar, can you? Yeah. Is it okay now? All right.
Yeah. Hello. Yeah.
Cool.
Okay. Yeah. Fine. Yeah. So where was I? I was saying that the orientations of different buildings or the planning and architecture of some cities were focused on the astronomical events and basic our basic astronomy.
Right.
So there is this Sthapatya Veda, which
Okay.
is which is about the Indian tradition of the architectures. Indian tradition
Oh,
of the architectures.
really?
So yeah,
Tapatya Veda.
actually Sthapatya Veda. I don't
Yeah, yeah,
know
yeah.
the pronunciation, but still,
Okay.
yeah. So this Jaipur city was designed according to that,
Damn.
our city of Jaipur. So Vidyadhara was the designer, and it is actually 9 squares. 9 squares are they signify the universe, where the central square is occupied by the Earth. So this universe at that time was our just solar system, and
Right.
as we know that it was Earth centric. They say that the central square is occupied by the Earth.
Right.
So, in a similar analogous way, he designed the city according to 9 large squares in the city, and the central square allocated to the royal palace.
Wow. Okay, I have a couple of questions. One, so that means that they knew there were 9 planets back then, obviously. And two,
Yes.
uh, even in what was it, Roman or Greek? So Copernicus was from where? Greek,
Greek.
right? So there he was, what, he was killed for saying that the sun was the center, not Earth, right?
Not killed. He was
Ostracized.
taken in court. Yeah.
Okay.
Galileo, yeah.
Galileo said that.
No, even Galileo said that. Oh,
Yeah. So
Even Galileo said that.
so that means that there was a time when even in Greece and in India, they both had the same belief that Earth was the center.
yeah. And like, if
Okay.
we go more into the conversation, we'll understand why they thought that, and it's reasonable to even think that at that time.
Okay, understood. Okay, continue. Atal?
Yeah. So
Galileo was hanged for that.
yeah.
Kalpa
So
just saying. Yeah. All right.
yeah. So this was one of the examples in Indian literature. There were many. So there is this temple in Cambodia. That is a Hindu temple actually. So it has also similar architecture kind of thing.
Right.
Yeah.
Okay.
So also this is just about the Indian civilization kind of thing. We also had this in Egyptology. So in Egypt, the Pyramid of Giza.
Yeah.
So yeah, in this Pyramid of Giza basically are 3 pyramids, right? Spaced at a particular distance, and their size is also in a particular proportion.
Yeah.
So there is this correlation between the pyramids of Giza and the stars in the Orion belt.
Okay. So the way they are arranged.
Yeah, absolutely. The way they are arranged.
I have a picture of that. Wait, I can.
Okay. Yeah. I think I've allowed sharing. Go on.
Yeah.
They're oriented. Yeah. Saurabh is saying they're oriented to the Orion constellation. Super cool.
Yes, absolutely.
Let's do flat earthers raid and confuse them. Yeah, why not?
Yeah. So yeah, this picture is the superposition of the Pyramid Giza and the Orion Belt's 3 stars.
Oh, wow. Okay.
Obviously from the top view.
Yeah.
Yeah, and interestingly, the what you call that? I forget the name actually every time.
What?
The Leo type lion shaped Great Sphinx.
Yeah.
Yeah, that Great Sphinx.
Yeah.
Yeah, so that is based on the constellation of Leo.
Okay. Oh, acha. The
shape of it. Yeah.
Right. Yeah.
Yes, and this Pyramid of Giza, that Great Sphinx and the Nile River are specifically oriented in the way where the Great Sphinx refers to the Leo constellation, the Giza refers to the Orion's belt, and the Nile River refers to the arm of the Milky Way.
So they made the Great Sphinx and so both of those structures they made along the Nile in a way that it resembles
this particular arrangement.
Constellation. Okay, this arrangement.
Yes, this particular arrangement.
Okay. So they were literally copying the structures they could see on the sky.
Yeah.
In a
Yes,
There
way.
are
absolutely.
Yeah.
like there's a Stonehenge ka example as well, that maybe it is based upon astronomy,
Uh-huh.
but like it is trying to get the summer solstice between the two rocks, the main line. But then it's just a speculation. It's not
It's not
proved yet.
proved. Yeah, I've heard about this, but then there are a
Yeah.
lot of theories about Stonehenge.
Yeah.
Yeah, and the part of the mystery is that we're not sure exactly what it is.
The pyramids are like the famous ones
Yeah,
out.
there are.
Yeah, understood. Okay.
Yeah, absolutely.
So,
Uh,
yeah, this idea of the time is really interesting for me. The way that in the earliest days, uh, now we look at the clock, but earlier they would look up at the sky to
yeah.
check time, date, year, month, whatever they want. They would look up at the sky, and that will be like their calendar.
Yeah. So we're
And
gonna start with that.
start with
That's like a good
Yes.
segue to the conversation.
what? Okay, you're gonna tell us about calendars. Okay, awesome.
Yeah, yeah. So for that, we
Yes,
have to forget
calendars.
everything that we know. Just wipe it off your
Okay,
brain.
done.
You don't know
Forgotten.
anything. Yeah.
Forgotten.
You
Done.
are on Earth for the first time, let's say. And the first thing you notice, just baki ka distraction agar hataya to, is the lights above us.
Yes.
There'll be one very bright light at some point, and then after a while it gets dark. There's small tiny lights and a little big one.
Yes.
Slowly we wonder about them. We give them names: the sun, the moon, the stars,
Yeah.
and our entire study of how can we survive this life depends on that, because these stars or the sun, the moon, their position seems to be controlling our lives in a way. So if you see something above you that is controlling your life in a way कि oh अंधेरा हो रहा है अब light आ रही है अचानक से, or there are seasons
Yes.
and you're like, so they are like OP वाला चीज जो है ना, they're like gods to us, right?
Sun OP, guys. Sun OP and Moon OP in the chat.
Sun, okay.
Yeah.
YouTube will be like, dude, ये लाइव स्ट्रीम का चैट कुछ अलग ही है. Okay, continue.
So that is how we started with the entire idea that the gods are watching on us from above, because
Right.
everything that is controlling us is above us, right?
Right.
That is how we started with the entire concept of religion, and then वहाँ से astrology भी आने लगा धीरे धीरे.
Because they
And
are
then that-
controlling our lives.
Yeah. So
And-
it made sense.
Yeah, and part of human behavior is as soon as you figure out something, whether you figure it out right or wrong, it doesn't matter. As soon as you figure out something, you try to manipulate it and
Yeah.
say, okay, now that I figured this out, how can I predict? So now that I know, okay, this is
Or
how-
basically, if you are not able to figure out something, then you, it's like giving a self explanation of,
Yeah.
okay, now I understand because I have given this explanation.
Correct. And that is actually, to be fair, that is true at every level of knowledge. We are even in science, we are always telling ourselves that, okay, now I know, but 10 years later you realize, okay, I didn't know. So at every level you are doing that, but we are no different. I mean, from the Stone Age people till today, that concept has always been the same, that we will look at something, find an explanation. That is step one. Step two is, how can I use this information to predict what is going to happen and use it to my advantage?
Yeah.
So, right, that makes a lot of sense.
Yes.
Astrology will come in. Now, the sun has been like this, the moon is like this, therefore you are going to have a boy.
It
or
will
whatever.
come in and then go away also. So
Yeah. Okay, continue, Meenal.
Okay. So once we give them names, हम लोगों ने बोल दिया they are gods and everything. And at that time we can't afford to try and figure out the physics of that, because we have to survive. We have to keep ourselves alive.
Yeah.
So we're just like, okay, let's keep that away for a while and let's figure out what it is. And slowly over a period of time, let's say 100 years, we notice that there are patterns to these seasons and everything. And we're like, oh, so this thing that it has a flow, and we name it time.
Hmm.
And as we go with the flow, we realize ki, oh, there are some things that we use as time markers
Hmm.
to understand what is going to happen next, what you said about prediction.
Yeah.
And that helps us survive. Since we can predict, we can, let's say, if it's going to flood, we can go up the hill and save ourselves.
Yeah.
And that is how we started with using astronomy for our own survival. We directly interacted with that.
Absolutely. Yeah.
Even on a day-to-day basis, like high tide and low tide, once
Yeah.
you start fishing, that becomes such an important marker, because that will decide your entire decision making, or agriculture,
Livelihood, actually.
livelihood.
Yeah.
So agriculture and rain, which has everything to do with seasons, which has everything to do with sun and the moon relations.
Yeah.
So
Yeah.
yeah.
And when it comes to your life, when it comes to you want to live that thing and you want to survive in this, I don't exactly remember the story where actually this sole thing of survival was um, used as a frightening tool uh, by some guy. Yeah, do you remember that,
Yeah,
Minal?
yeah, yeah.
I just
So I'll come to that thoda time hai,
Okay.
because then you said
yeah,
something.
okay.
So as we get the time markers that we use, there are three. One
Okay.
is the revolving heavens. We used to call the sky heaven.
Right.
So the sun going from east to west was
Hmm.
our marker of a day.
Yeah.
That is how we define the day.
Yeah.
Hmm.
And then comes the phases of moon. We realized that it has phases,
Yeah.
and that is how we use that to define our month.
Hmm.
And then for seasons, we use the position of the sun in the sky, because okay, I have a picture that I can show actually. Just a minute.
Occam's razor. So Sparsh has some really good comments I've noticed. Occam's razor is saying that the simplest solution is the correct solution, and that is true, because a lot of things that we now
Yes.
consider as superstition or silly was Occam's razor at one point.
Yeah.
That was the simplest explanation, and there was nothing to prove against it at that time. The only problem is that with new evidence, if you don't change your view, then it's a problem. There's
That's a
Yes.
very good point. Okay.
yeah. Tell me.
So
Uh,
okay.
can you open it? It's not opened yet.
You can't see?
No, you have to click on it. Like I
Okay.
can
Folder
see.
ही open है सिर्फ.
Ab dikh raha hai?
Just double click on sun's position in a year.
Double click on the icon, I
Or
guess.
is there a lag? Huh? Just double click on it.
Yeah, I think there was a lag. You can see it, right?
There is still a
Right.
lag, but yeah, I don't know why it's not opening though.
Well, anyway, I'll just explain it essay. We don't
Sure.
need technology for
Sure.
that.
Yeah, we've all seen sun's positions.
Yeah, so this is the horizon.
Yes. Yes.
Yeah.
That is the horizon.
Now,
Make it curve.
during winter,
Okay.
or so this is the horizon. When it's December, when it's cold, the sun is actually very close to the horizon.
Yeah.
Okay.
At a particular
and
time,
when-
you mean?
Yeah, like at a particular time during the
Yes.
year,
Yeah.
when the sun is closer to horizon, we feel cold. So we gave it the name winter, and then it's a little above to the what it was there in December,
Yeah.
and that's autumn and spring.
Hmm.
And if you go a little above in the altitude, then it's summer.
Okay.
So we noticed that the sun's position actually changes the temperature on the earth.
Okay.
And that is how we got seasons in our
Oh. Okay. 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 Got it. Cool. Yeah. That's a very nice way of looking at seasons. Equinox. Yeah, that's
Yeah.
what the word is. Equinox, right?
Equinox.
Yeah.
Yes.
Lovely.
Yes.
So we figured all of that out, ki equinox and the summer solstice, after like when we started going out of Earth's atmosphere.
Right. and we got a better view of the whole thing.
Yeah.
Right.
Like we had an idea.
Yes,
We had
yes,
a
yes.
theory for sure.
Yeah.
But it was just in theory.
We should talk about rockets. But yeah, we will. We will.
Yeah, we will.
Yeah. So
Okay.
Ashmit said Occam's razor doesn't say it is correct. It should be preferred as it is more likely to be correct. Yeah, that's fair. Yeah, that is fair for all logic, I think.
Yeah.
Yeah. Okay.
Yes.
That is,
Cool.
I mean,
Continue.
whatever that helps us survive is good enough, even if it's for a small amount of time. Basunda rehna sabko.
Yeah. Yeah.
Okay.
Why?
Bol.
What were you saying?
No, people were appreciating your hoodie. I just thought I'll mention it to you.
Oh, thank you. I love it. It's really comfortable.
Okay, continue.
All right. So now we have seasons, we have months, and we have a day.
Yes.
Now, I was thinking about this yesterday. It's just a random thought that I have never lived like in my 20 years of existence, ek din aisa nahi tha where I haven't checked my phone to check the time instead of looking at the sun. Right.
True.
In olden times, people used to look at the sun and they could tell the time of the day. Like just,
Yeah.
So we were so observant about our surroundings, and that has helped us move forward as a
Yeah.
civilization.
So do you want to say technology made us handicapped?
No, we would always fall down to the least required effort.
Yeah.
Like that's the way we are built. So
Least energy principle.
least energy principle, right? So if you end up on an island without the phone and anything else, probably in 10 years we will also figure out,
Yeah.
right? And to the dot. But we don't have to, thankfully, so we don't. So
Yeah.
it's actually a very efficient way of living,
Yes.
right?
And it saves our energy from just trying to survive, and we can create more things.
We can create more things, exactly.
Yeah.
So yeah.
Absolutely.
Infinite monkey theorem. No, infinite monkey theorem is very different. I don't think this is what infinite monkey theorem is. But what is the automation paradox? I'm not sure what is automation paradox.
I haven't heard of it as well.
Yeah, I mean, Sparsh, can you explain what is automation?
Which paradox?
Automation paradox.
Oh, no.
Probably about
Nah.
like how we create smarter technology, and so we don't have to be as smart or something like that.
Like Wall-E, the movie.
Wall-E, yeah, probably something like that. Infinite Buggle theorem. I guess that's your friend Rishabh Singh.
They are spamming throughout the chat.
All right, continue.
Okay, let's get back to calendars.
Yes.
Okay. So once we have figured out the time and everything, now we are going by. It's all fun and
Yes.
happy.
Chal
We're
raha hai.
surviving. Now I'll just give a little glimpse into the types of calendars we have had.
Yeah.
We have had more than 25 calendars.
25.
The one we are using right
Yes.
now, it came into 1572, around that year.
Okay.
Gregorian, right?
Gregorian.
Yeah.
Huh.
So it's a very recent one. But Egyptians, I love their brain. Okay. So they used the flooding of River Nile to define the year. They use okay, this is the time it's flooding, and now they count the days till it floods again.
Yeah.
And then it's like 365 days. They got the exact number. It's
Yes.
speculated that they knew it was 365 and 1/4
Damn.
days. But then they were like 1/4 ka kya karna hai? Just leave it, round off karna hai, perfect number chahiye. But that caused a problem for them because after 120 years, they had an extra entire month because those days just kept on adding up.
So then the leap year came.
Yeah, like a long.
Oh,
Yeah.
it took a long
A
time.
lot
They didn't
after
figure
that.
it out then.
No. It was, I guess, Egypt.
Actually,
Yeah, bola.
yeah, these extra days also caused one calendar, I don't remember the name, to just skip days in between the month.
मतलब
Yeah.
13 से
Julian
15 चला गया, 14 था ही नहीं ऐसा.
1, 2, 5, 13, 17, 18 ऐसे इतना skip.
Just imagine if your birthday falls on those days. You'd be so pissed off.
It was, I guess, Pope
Absolutely.
Gregory did that.
Okay.
he
Ah,
realized
yes.
the calendar we was using before, that is Julian calendar. So Julian figured out, oh, there were errors in the calendars, and he tried to fix it.
Yeah.
So there was a time when there were just 10 months in a year. And yeah, the rest, it was like around 304 days in a year. And the 61 days, uske baad, they were just not counted at all.
मतलब
Like,
denial. छोड़ अभी हो गया.
हो
Damn.
Ah,
गया.
yes.
Dude, Ashmit said Julian calendar. Damn cool, yeah, Ashmit. सही है.
Yes, yes.
GK
Okay.
GK for the win. Okay.
Okay.
Then
Ashmit Jetli.
yeah.
So the one,
हाँ.
yeah,
बोल.
I was saying about Julian calendar. Julian calendar mein, he added days. He realized that we had missed around 61 days or 67 days in a year.
Yeah.
So he made like entire 12 months. He gave 31 division to the months. And since he did such a good work, people were like, oh, Talia. And they named a year, a month after him, that is July.
Oh.
July.
And it has 31 days because he did the maths and everything.
Damn. Okay. So wait, do all the months have a story behind it?
Yeah, we have September, October, November, December because there were 10 months in a year. So it's like, 7th, 8th, 9th, 10th.
Okay, September. Oh,
Yeah.
okay.
So,
All right.
But yeah, many have the story behind them.
yeah. I just didn't go into that.
Oh, okay. So 10 months, so 7, 8, 9, 10.
Mhm.
And then बीच में दो ऐड हो गए.
Yeah.
कौन से ऐड हो गए?
Huh.
So July and August.
July.
June and July, I guess. No, July and August. July and
Yeah.
August.
Because his
अच्छा.
grandson, Istika, Julius,
Augustus, right?
Augustus. अच्छा. तो उसका भी एक ऐड हो
Yes.
गया.
and then July and
हाँ.
August both have 31 days now. Because,
Oh, because yeah.
Because he was Julius' grandson.
क्योंकि उसको कम कैसे दे सकते हैं? Damn it. He'll be like, नहीं मेरे सारे दोस्तों के पास 31 है, मुझे भी चाहिए. Okay.
Yeah, and he fixed a lot of errors. And I was looking at the maths of these things. It's amazing that the calendar that we are using right now is correct to the point that only after 3,333 years, there'll be an error of 1 day or something.
Okay. When is that day coming?
I don't know. But
After
we kind of,
3,333 years.
No, from today.
No,
I mean, there has to be
No,
one.
not from today.
Yeah, there has to be one day, right? Like where it's expected to. When was the last time that error came?
No, I guess from the day the
Gregorian.
calendar started. Yeah, yeah.
Right. So 15th century से गिनो आगे.
But then
yes.
try to correct that with leap year. So I am not sure if that's gonna happen.
Okay. Acha.
Yeah.
So when did leap year get added?
Usi time, like
Usi time.
Yeah, he was like
Very well thought out.
years divisible by 400. You just are leap year. That's it.
Brilliant. Okay.
So I have a picture. I hope वो share हो जाए because
Yeah, हो जाएगा. Ashwini, we should get some content related to machine learning and astrophysics. Wow, those are like two different interesting.
No, they are not actually different.
No,
they
it's
have
not.
a very nice intersection. They have a very nice intersection.
Yeah.
I'm working in that itself right now.
Oh, lovely. तो फिर करते हैं फिर एक बार. मैंने coding का शुरू किया था because I wanted to get to machine learning and neuroscience because neuroscience और machine learning में काफी similarities है. तो
बहुत similarities है.
Oh, yeah.
इधर भी है बहुत है.
We can see.
Okay.
So we can definitely
yes,
do that,
yes.
Athar. We can do neuroscience, machine learning, and
Yes,
astrophysics.
absolutely.
That'll be super fun.
Astrophysics, machine learning.
Yeah. Cool. Bol.
Okay. So Chaldeans were some people in history who had 7 gods, and the concept of week comes from them. Actually, there was a time when there were 10 days in the week. But then people were like, "मैं थक गया."
Because the weekend will come only after 10 days.
Weekend.
Yeah.
Like how work from home is for a lot of people. There is no weekend for a lot of people now. Oh God. Okay, so
Lockdown, no weekend. College, no weekend.
yeah, it's just work now. So there is no, literally, dude, this is such an interesting topic because the pandemic has really screwed up our perception of time.
It
Because
has.
you are not going out, रात और
It
दिन में
has,
कोई
it
फर्क नहीं
has.
है, and who knows what day it
There is
is.
no night, day, afternoon, evening. Day. There is sleeping time, eating time, working time. Repeat.
Like it's working time unless proven otherwise.
Yeah.
It's working time unless you're hungry or sleepy. That is the reality for a lot of people. Okay,
A
so
lot of
I saw this
activities.
video on the internet also.
yeah,
So he suggested making Wednesday a weekend and skipping Saturday, so midweek weekend,
midweek, yeah. But then
so
those,
that people get a recharge in the midweek, and then
yeah, long weekend तो नहीं हो पाएगा ना लेकिन. I was actually
Exactly.
thinking of taking a break on Wednesdays, like not go to work on Wednesdays. Like Monday, Tuesday काम करो, Thursday, Friday काम करो, बस. Let's see. अगर
wow,
होगा. That'll be a good.
wow, that's a good one.
Don't tell my patients. Okay, so when did this happen? When did this switch happen to 7 days?
This happened, with the Gregorian calendar itself.
Okay.
Like Julian calendar के साथ ही आया वो.
Okay.
I mean this whole, but this Chaldean thing. So this is way before Egyptians as well. Like the Babylonians के साथ है इनका.
Yeah.
So they had 7 gods, and these were the planets like Mercury, Venus, and Jupiter.
Yeah.
This is same
They
in
gave those gods.
Hindu culture also, right?
Yeah.
Yeah.
Mercury,
Venus is Shukra.
Jupiter. Yeah, correct.
Yeah.
Yeah,
So the closest,
same.
the closest 7 basically,
Yes.
right?
Yeah.
So they didn't count Uranus and Neptune.
Mhm.
They counted till Jupiter.
I think Uranus and Neptune aren't
Saturn
even
also.
that
हाँ,
visible. Yeah.
so Saturn comes before Jupiter. No, Saturn comes after Jupiter.
After.
Yeah. So
Yeah.
After
Saturn
Jupiter, before Uranus.
before Uranus, right? तो Sun को गिन लिया और
Yes.
फिर बाकी planets को गिन लिया. ठीक है. And Moon is never considered a god. No, Monday, of course. What am I doing? Of course. Continue. बोल.
So ये लोगों ने वो gods को काम दे दिया. Like they gave them the job that 1 hour during a day you just look over us.
Yeah.
And that is what the gods did. They didn't give them the job, but yeah.
Oh, okay. That is the concept. Yeah.
If you go with it, it's like on Monday, Moon watches over you, Moon God. And then on Tuesday, the Mars. And then Wednesday is Mercury. Thursday is Jupiter. And then Friday is Venus. And Saturday is like Saturn. And then Sunday.
Saturn.
Okay. And then Sunday is Sun, and again Monday is back to the Moon.
Yeah.
Got it.
Yes.
Got it.
So, like these are way before Indus Valley civilization on a cheese as well. Like,
Yeah.
around that time, I guess.
Yeah.
But just thinking that same people, same sky with so many concepts, it just baffles my mind all the time.
Like everybody had their own version of reality of the
Yeah.
sky. Okay. How did they know this? Like, how were they able to see it?
See what?
Like, see Jupiter, see Saturn.
Okay, so if you look up at sky,
Hmm.
the stars and planets, at first you'll think everything is twinkling
Right.
stars and everything, right? But after a few years of observation, you will realize that stars are different from planets and they move differently in the sky.
To the naked eye also.
Yes.
Yeah,
Right.
you can see
The speed
Saturn.
of moving also.
Yeah, even like they follow a certain path,
Hmm.
and
Yes.
planets don't twinkle.
We'll come to that interesting path also.
Okay.
Huh.
Got it.
There
Got
is
it.
an interesting path in there. And yeah, the stars have this cross type of thing. The star in the center, like it represents this twinkling, and
Yeah.
Yeah.
And yeah.
Planets don't.
All right. Cool.
that's what it got the star shape actually.
Yes. Understood. What else? What
Yes.
next?
Okay, so now we have defined all the calendars. We know where we are at with calendars. We know
Yes.
why they were there.
Yes.
Now, after calendars, we are settled. We know agriculture अच्छे से चल रहा है. Now we are like थोड़ा explore करते हैं, and then we go to the sea.
Yeah.
And now starts the navigation वाला process. whereas we use constellations in the sky to understand where we are.
Directions, where, yeah.
Even there were
Yes.
small instruments that we use. And I think Athar can explain that what it
So,
is.
yeah, like when you are in the middle of the sea,
Hmm.
you literally are directionless otherwise. You can't know how
Yes.
there is nothing. If there's no landmass, you could be going in any
No,
direction and you won't.
you can actually know the directions like east, west, north, south by the sun. But
Hmm.
an interesting thing is there when there is a cloudy sky, you don't exactly know the sun's position.
Wow.
You
Yeah.
just know some area from where the light is coming,
Yeah.
right?
Yeah. Correct.
Yeah, so these were this Ireland people called Norsemen,
Yeah, of
or
course.
famously called Vikings.
Vikings, of course.
Vikings.
Yes. I can't wait
Yes,
to play
so
Assassin's
they
Creed,
used
the next one. Yeah.
yeah. So these people used a particular physics and also obviously astronomy
Uh-huh.
to get this. Yeah.
What is
So this
this?
is a crystal of calcium carbonate,
Okay.
or known as the sunstone, as they referred it.
That sounds so much cooler. Yeah.
So basically, this works on the principle of birefringence,
Okay.
the physics principle.
Right.
So basically, when the light passes through it, there would be two circles like this. So there will be overlap, and when they come exactly upon each other, you will have the what you call that. You will see that this light is coming from the sun, and when you go this, then basically you are moving away from the sun.
Oh, so then they can
So the
exactly
shadows
figure out
intersect, and yeah,
what
exactly.
direction they're going.
Yes. So on the screen, if you project this on the screen, you can see those two dots and those two shadows basically. Obviously,
Right.
there would be shadows.
Yeah. Okay, so
So this was used.
this is a way to judge direction. Probably before compasses came, this is how they judged
Yes,
direction.
Yeah.
Okay.
yes.
Got it.
So basically, this was used, and then they navigated themselves to western shores of England, or I guess Iceland, and
Yeah.
also the Americas, which is known as the current Canada.
Right. Oh, Vikings went to Canada. Okay. All right. Cool. And then compasses came.
नहीं उसके बाद बहुत सारी चीजें हैं.
Yes.
बहुत सारी चीजें.
Meenal is like, please let me. Okay.
There is a complicated thing which came, which is known as a sextant.
Yeah.
Yeah,
Meenal, please.
Yeah, I've heard of this. Huh.
Yeah.
What is this?
So before sextant, I just wanna like थोड़ा दिमाग शांत करने के लिए. There's this thing that we used instead of like the stars. The stars weren't always useful.
Yeah.
So they used birds to identify if the land is nearby. So what they'll do is cage a bird and पानी में जाएंगे, and they release it. If the land is nearby, it will run towards that direction. They'll follow that.
Yeah.
Or if the land is not near, it just hovers around above the boat.
So that it can come back to the boat because it has nowhere to go.
Yeah.
Oh,
And we
okay.
use birds. And birds have a great navigational thing because then they can fly.
Right. So birds are sort of
That
born with
pigeon
that.
exporters.
Yeah. So then they can literally chase the bird. You're saying they can go in that direction.
Yes, actually,
Yeah.
absolutely.
So this is an interesting thing about birds. So apparently, like their brains aren't as big, obviously, but they have this thing called the cerebellum, which is much bigger.
Yeah.
And their sense of
Yes.
direction is much better than ours. And at any given point of time, like even if they are blindfolded or whatever, if you release them, they kind of know where they are in like geographically, which is incredible. Yeah.
Oh, so that's why pigeons are used for all that.
Correct. Yeah.
Yeah. Okay. So now let's go to sextant.
So somebody said in chat that Australia is a hoax by the government and the world is flat. So excellent. We have
Yeah. Well,
That's my
just
friend too.
Very cool. We
we
have
can
all.
just conclude this talk now,
Yeah,
and
yeah, it's done. Guys, great talk. Thank you. Yeah, tell me, Meena.
all right. So for sextant, I have a set of pictures. Okay, let's see. Hmm. So a sextant, it looks like this.
No, it's
It,
not opening. So I think when you're opening your Finder, it
uh-huh.
doesn't open.
Double click it on.
All right. Is it
Yeah, probably
visible?
this is better. Yeah, okay.
All right.
You can
Okay.
enter full screen, I think. It is full screen. Okay. This is enough. This is good.
So this is a
Yeah.
sextant.
Yeah. Oh,
It has a scale below.
like a
And
protractor.
yeah,
Hmm.
and there's a
Hmm.
telescope. It's not filled with a lens. It's just a pipe that you can look through.
Right.
Okay, and then there is this mirror which is at the top, which is attached to this handle.
Hmm.
So when you move the handle, the angle at which the light touches the mirror changes.
Will change.
Right.
Right, right, right.
So it is used to change the angle, and it helps us understand where we are at, like हमारा altitude, longitude, and all that stuff.
Okay.
So
Yes.
on the other side, there is a mirror which is half mirror and half open. So I don't know if I have a picture, but like, let's see. Yeah. So let's say half mirror hai and half open hai.
Got it.
Okay. So it's this mirror. And these three things, they are shades that we use for our eyes ka protection. Pirates, we noticed that unka aankh ja raha hai, they used to have
Yeah. The patch.
yeah. So just to protect their eyes, we had shades. And this is the structure of the sextant.
Damn.
Now
Okay.
it works like you move it, you see the angle changes. There's a change in the angle.
Yeah.
And you can see is mirror pe where what object you're looking at.
Right.
Now, if the sun is above you, right? So you'll move it, and then once you see sun in the mirror over here, you try and align it with the horizon, so that once you go back and to align it with the horizon, you have to change your position as well, right? So like you get the position to the horizon straight, and the angle changes from the niche wala handle.
Got it.
And since
Yeah, this is interesting.
that happens, and then you measure the angle on the scale, and you understand, like you do some maths. There's a very different maths for this, and you get the position in this. Yeah.
Right. So all of this is for all of this is so that the sailors could judge where they are
Yeah.
and sort of document it so that in case they want to come back, then this is the position to come back to.
Yeah.
Okay. Understood. Okay.
So that's a sextant. And I mean, I have explained it in a very like basic wala cheese mein. Since the ships were a bit wobbly, so
Yeah.
keeping the horizon straight and everything, it was a task, and I
Right.
don't know how they did it. But yeah. Good for
Well
them.
done. Well done. Well done,
Good
sailors.
for them.
Okay. Then
So basically, their observation would be equal to their percentage error itself.
yeah, so probably they really wanted to get to the next thing. So how happy were they when they discovered the compass?
Oh, I think yeah.
When did that happen? Do you know?
They would.
That happened in it happened in sometime in AD. Like
Okay.
I don't remember the exact year.
Cool,
but
cool.
yeah.
Cool.
Chinese, I guess the Chinese were the people who actually came up with the concept of that first.
Right.
When they saw that some paper clips, steel ki cheeze, they were
Yeah.
sticking to a rock and pointing to a direction.
Right.
At first they were like,
Yes.
oh, Bhagwan हमें दिशा बता रहा है, हम लोग
Sure.
जाएंगे.
Sure. And then they realized magnets.
Yeah, and then
Yeah.
they made the compass with that.
Okay.
So that's how the compass works.
Okay.
Not Bhagwan. Compass.
Tell me,
Magnetic.
no. The idea of so we have started from the Stone Age.
Yeah.
Stone Age looked up at the sky. Stone Age women looked up at the sky, figured out time, figured out days, months, years, figured out seasons. They
Yeah.
figured out calendars. they started going into the sea. They first started agriculture. Their knowledge of calendars helped them with agriculture. They learned, they grew enough to develop, to make boats. They went out into the sea. Once they went out into the sea, again, astronomy, planets, stars helped them in their directions.
Yeah.
So, in our attempt to understand astrophysics, we are sort of starting right from the start, going through astronomy, because that is what laid the foundation to astrophysics.
Yeah.
Right? Okay.
Yes.
So how does, or when did astronomy become astrophysics?
This came because of this is the physics process is generally, we can explain it by it's standing on the shoulders of giants.
Okay. So what happened there?
So
let's,
like,
moving on to astrophysics.
This one guy will do some work, extensive work. You develop your work upon that work. So take that as a base. You stand on its shoulders. You see the world.
Right.
So it goes on like that.
So
this basically gave it a boom when Newton mechanics, because that was the thing which explained the planetary orbits and everything like that.
Kepler and Copernicus and everyone. Those
right. So
people
all
Yes,
of them,
Kepler,
Galileo, Copernicus, Kepler. Okay. So before that, yeah, tell me.
Yes.
You tell me.
Okay. So before that, so let's see. We have calendars now.
Yeah.
We know how to navigate.
Yes.
So sorted. Now we have enough time to try and question different things. Why are planets moving the way they are? And since we did not have something through which we can look through, right? So it was kind of difficult.
Right.
And like a blessing, Hans Lefaucheux, this guy, he was an eyeglass maker, and he just put two lenses in front of each other, right? And he realized that it magnifies the thing that is in front of you. And okay, then he tried to make a telescope out of it. And so then Galileo, like a lot of other people in Europe, then tried to make their own versions of telescope. Galileo had the best one. So that was the first time we used something related to that physical phenomena to look up at the sky. And using that, he actually understood a lot about the structure of the moon, the craters. And if you Google his drawings of moon, they are so beautiful. His notes are so beautiful. So
really, I have to look it up.
I think I have them.
Yeah.
But
this was the thing actually. Now these guys started understanding how it works.
Right.
They wanted to explain how it works using some postulates, as we call. But there were some people who just wanted to convince themselves that they know how it works, and therefore we get across the mythologies.
Acha, matlab, obviously, there'll be some people saying that.
So like Greek mythologies.
This is why the world, the stars and planets are behaving like this, and they want to hold on to that belief.
Yes.
But
some are like, now there is this 12 constellation thing. So basically, the Greeks designed those Scorpion, then are Orion and Taurus, Leo, Canis, and everything like those. So basically, there was this thing. There is this interesting thing about that. So basically, Orion and Scorpio, you can't see them in one sky.
Okay.
Never. These constellations, they are always opposite to each other. That's because so they are chasing each other. This is Scorpius and Taurus. So this Taurus over here is Orion. So they are always chasing each other because Orion is on the Scorpion is on the hunt of the Orion, which is hunting the Taurus, which is the bull.
So Orion is which one here?
Over here, there is no particular Orion thing, but the Taurus. So this Taurus has a V, large V in the top of it.
Yes.
So that is the those are the horns and the head. So just next to it is the Orion, which is pointing towards Taurus,
Understood.
pointing its arrow towards the Taurus.
Understood.
So
Understood.
these are the stories which these are the type of stories which they try to create.
Yeah. So,
But there was this one particular story which I like, a concept which they introduced.
yeah.
That was the concept of gateway of heaven. So when I heard it for the first time in my 8th grade, I was like, oh, that's
What
like
is it?
just mind blowing. So there are this Castor and Pollux, two constellations,
Okay.
and the bright stars in those two constellations named Castor Alpha and Pollux Alpha.
Mm-hmm.
So these two are situated like this, and then you have to the right of them are Procyon star, which is one of the two in Canis Minor.
Okay.
And then to the left of that, you also have one faint star. I don't remember the name exactly, but still. So this forms a parallelogram like this, a bit.
Like a door.
So yeah, a door, a gateway of heaven. So basically, through that path, all the orbits of Sun, Moon, and all the planets pass through with respect to Earth, obviously.
Whoa. Acha, and that is
So
an
that's
actual
why they
fact.
called it the gateway of heaven.
Yeah.
Oh my god.
Yeah, that is an actual fact.
Damn, man. Okay. Very cool.
So that was the thing that got me like, oh,
ये तो पढ़ना
this
है.
is some interesting field to go in.
Amazing. So gateway of heaven is where all the orbits of sun and moon pass through, and it actually goes through a door shaped constellation.
Sun, Moon, and all the planets. So yeah,
How can
all
all
the
the
planets
planets
also.
go through that? Is that possible?
Not one at a time, but
Yeah, of course.
yeah, just one at a time, obviously.
Damn. Okay. Very cool. I had no
It
idea.
just does.
I didn't even know about Gateway of Heaven. Okay. Lovely.
Yeah.
Lovely.
But these stories kind of like acted against us as well. Like Columbus, we know he was a bad person, but
Sure. Okay.
there is a story of him like going to America and asking the Native Americans for food,
Hmm.
and they reject him. Okay, we are not giving you food. Why would I give you food? So he said that after like a few days, the moon will disappear from your sky, and it is because you said no to me. So now he was very well versed in his astronomy because he was
He was
sailing
a
around the
sailor.
world.
Yeah.
Now these people who are so isolated from the society, they were like, okay, and we are not believing him. But
Yeah.
then when the moon thing actually happened, they got
Right.
so scared that they had to give in. And
Hmm.
it's just like people in power, the entire power dynamic, and how if we are not
Wow.
scientifically literate, how it can
Yeah.
affect how we can be manipulated so easily.
Oh wow, that is a whole other correlation. I love it. So yeah, that's true, because anybody who has more knowledge than you can use that to their advantage,
Yeah.
because you will see the world with
Yes.
whatever knowledge you have, and you will always think you know.
Yeah.
Just like everybody looked up at the sky and thought they knew what is going on, but somebody else might know more, and then if they tell you something, you will see it in your way and believe them.
Yeah.
Oh wow. Okay. Lovely. All right. So okay.
Yeah,
Go
there
on.
is this comment which I read,
What?
some by Win Cool.
Uh-huh.
In the universe, there is no center, so you are the center.
Oh no, I think some wait, didn't Neil deGrasse Tyson have a comment on something like that? So you can't be the center, he said. If there is no
Yeah,
universe doesn't have a
Yes.
center, so you can't be the center of the universe.
That's
Yes.
expanding like infinite.
Yeah,
the
exactly.
center.
Exactly. Okay. Yeah.
It
continue.
will contract sometime soon.
Oh god. Okay, we'll get to that. Not before chat ends, not before the stream ends, don't worry. That reminds me of
okay.
Hitchhiker's Guide again, like the restaurant
Oh
at
yes,
the end of
Hitchhiker's
the
Guide to the Universe.
yeah, Guide to the Galaxy, and the restaurant
Yeah,
at
to
the
the
end of the
galaxy, yes.
universe.
The end,
Yes.
yeah.
Yeah, you can actually see the Prithvi
It's
saying, "Is that your pickup line, Bagul?" The
Arey,
universe is ending soon. Swipe right. The universe is ending soon. Not a bad one.
I mean, okay.
I
Who wants
mean,
to date in the last days of their life?
okay, continue.
Yeah. Also, like when we started sailing through the seas, okay,
Yeah.
we like according to that time, flat earthers were gone,
Okay.
but we still have them. That's a different story.
Sure.
I but
We'll
for
get to
that,
them.
yeah,
Yeah.
for that time, the flat earthers were like this theory was completely demolished, and they were like, "Oh, Earth is not flat."
Hmm.
And slowly, then came the entire model of Earth being at the center, and mostly because everything seemed to be, changing in your,
Around us.
yeah,
Yeah.
you'll be like center mein ho."
Yeah.
And we felt like we were some privileged people who are at the center, and we kept on going with that. So Aristotle, again a person in power,
Hmm.
he used to believe in that as well. And for around 2000 years, his views about Earth being at the center affected a lot of people.
Yeah.
For 2000 years, you won't see any person saying Earth is not at the center.
Yeah.
Then a few people came after that, and they started to come up with models of Earth not at the center and
Right.
where Sun is at the center, because there were a few phenomena of the planets which didn't make sense if Earth was at the center.
Like?
So there's this retrograde motion of planets. Okay.
Okay.
I'll try
So these
and
planets behave in a very weird way.
yeah.
Okay.
So
What is the weird part?
it's like so it's like you want to go to some market, but you go, but then you forget your wallet, you come back, and then again you go. So do you imagine that kind of path you follow?
So
You
planets
go, you
do
come
that.
back, you go.
Hey, planets
Yeah,
don't do
Mars
that.
does that. Yes, planets do that. Mars retrograde motion. So this is the thing. This is
Oh my
the picture of
God.
Mars, time scale basically.
Like a time lapse.
Yeah.
Oh my
Yes,
God. It actually takes a loop back and it goes in front.
Yeah.
Why would it do
yes.
that?
So that
Yeah,
is like,
it's an interesting theory.
I want to know.
okay, I'll tell you that. So Ptolemy came up with a theory of, I don't know what it is called now, but yeah, epicycle and different.
Okay.
So he was like, oh, Earth is at the center, but the planet is moving this way in its own orbit as well.
Uh-huh.
So, that's why we get these shapes. But then again, it didn't make sense, because then it should move further away and
Yeah.
then form the same loop again. But
Right.
that didn't happen. So after some time, Newton, or I guess someone came up with the explanation for retrograde, which was that we are not at the center, the star is at the center. So if I have a small video to explain that,
Okay.
mute it. Yeah.
Yeah.
So
I stuck a post-it note to the wall.
yeah. So let's say that there was a star, and
Uh-huh.
then she's following the orbit.
Yeah.
Now she takes a picture for every movement in the orbit, and if you render it, it's like, okay, sab to same hi dikh raha hai. But it's mostly because, see, the star is here.
Right.
So since the photos are moving and the star is not at the center, it will seem like seedha chal raha hai. But in our case, the star is at the center.
Right.
So now look, if she takes the star at the center, what happens? You can see the loop over
The
there.
loop.
Yeah. And
Oh my God. Okay, got it.
that is because
Yes,
of the
so that
orbit.
curve.
Yeah.
Obviously, and then you can, there's no other explanation if you're looking at it. Yeah, okay. Got it.
So when so Mars' orbit is bigger than our orbit. So the loop happens because Earth is trying to catch up with the Mars, and till then it has moved a distance, and we're just trying to catch up. And in that movement, since the sun is at the center, it seems like there is a
So
loop.
tell me this:
Yeah.
is the loop because of our perception of where it is? So suppose we are looking at Mars from, say, Alpha Centauri. Does it have a loop?
I don't think so. No, because
It's because of the relative position of Earth, the Sun, and Mars, right?
yeah. So
But
from
does
Alpha Centauri you won't.
Yeah, does the planet actually loop?
No, it does not. It's just,
Dude, you just made me question everything. Because why would a planet loop? Okay,
Yeah.
okay, got it. So because of our relative positions, the way we see it, it seems to loop.
Absolutely.
Yeah. If you're looking at it from,
Absolutely.
upper say it's not looping, right? It's just
But-
going around its
If
whatever.
you look it from a third, if you look at it from a third person point of view, like some random point
Yeah.
in space,
In space.
then everything is normal. Every law is satisfied.
Thank God. Okay. Cool.
but look at, like, imagine the plight of people back then who were like, "ये Mars से क्यों घूम रहा है?"
Yeah, exactly. Like in 2020, I was like, "Sab galat hai, sab." Yeah. So Atharva said
Simulation.
no
Wake up.
There's no up in space. Yeah, that's true. I said up there, but yeah, there's no up in space. That's true. Ankita,
Like,
also the orbits are not exactly circular. That's also it's sort of
That comes
elliptical.
in.
Yeah, elliptical and in different
Oh, yeah.
planes. Yeah. Cool.
That comes up in Kepler ke 3 laws.
Yeah.
It is right after this time that he came up with the laws, planetary motion.
Okay. What happened?
These comments are really crazy.
Dude.
There is no universe, it's Nepal.
What? I didn't even understand.
I don't understand.
Is that a joke? Is that an inside joke?
Yeah, that's a reference, right? So Nepal said that so the Ayodhya is in our country.
Oh,
So then everything was like everything is in Nepal.
of Nepal. Right. Okay, got it. Okay, Nepal OP. All right, continue. Okay.
Oh my god. Okay, I love people. Okay.
Yeah, people are awesome.
So after we figure out the retrograde, we are like, okay, now sun is at the center,
Yeah.
and we are moving around it.
Yeah.
Now, why planets move the way we do? Why do we move around the sun in this period of time? What's our orbit and everything?
Gravity.
Thoda
No.
time around.
Okay, third time more. Sorry. I get excited. Tell me.
So then came Kepler's law of planetary motion.
Okay.
So again, I am going to show diagrams because that is
Yeah. Go
Okay.
ahead. You don't even need to close the thing. You can just keep showing diagrams.
okay.
Yeah.
All right.
So what I can do is I can enlarge you when you are talking and enlarge the image when you are sharing
Alright.
something.
Okay,
Which-
मुझे दिख नहीं रहा.
Oh,
Why?
that's great.
Yeah.
Oh, why did it stop? Okay.
Only one part was visible of the screen.
Will we discuss general relativity? I don't know, Monk. Will we discuss general relativity? We'll touch upon it.
Not till the end of this one.
Oh,
Yeah.
wow. Stay till the end of the session to talk about general relativity. Yeah. Are you sharing?
No, I'm trying to share now. Okay,
Yes.
can you
Okay.
see?
Yes.
Perfect. Okay, now I want to find Kepler's law of motion. Yeah, planetary motion, I mean. Okay. So this is the first law.
Yes.
That's basic. We follow an elliptical orbit
Mm-hmm.
and the sun is at the focus.
Hmm.
And he figured that out using the same things, like, because, how do I say, the retrograde motion kind of helped us
Got
figure
it.
out the elliptical orbit.
Got it.
And the second law is that a radius vector joining any planet to the sun sweeps out equal areas in equal lengths of time. So even if you are here, this area will always
Understood.
be this in terms of time.
In equal lengths of time.
Yeah.
Right, because we are
Yes.
the arc is time, right?
Yeah.
Oh yeah.
Yes.
So यहाँ पे भी एक महीना है and यहाँ पे भी एक महीना है. It doesn't change at all. And then the third law is that the square, I'll just
Squares of the sidereal
sidereal
periods.
period.
Sidereal.
Yeah, of
What
the
is
sun.
sidereal?
Sidereal period. Sidereal periods. So
Yeah. So it is like position of the Earth with respect to a distant star.
Okay.
Yeah. And so, okay, sidereal में is measured कि एक star को वापस Earth में sky में दिखने के लिए कितना time लगता है.
Okay, so it's a unit of time.
Yeah.
Oh, okay.
With
Yes.
respect to a star which is not a sun.
Understood.
So basically, for the moon, it is 27 days.
Right. So same position में आने के लिए कितना time लगेगा? So can
Yeah.
you give me an example? So which is the commonest star that you use for a sidereal period calculation?
I think हमारा North Star is the one that has always.
Okay. North Star is what?
No, but we don't
Uh,
use that as sidereal period calculation. It's just there. It doesn't move
Okay.
Yeah.
with respect to us, obviously. Yes.
Oh yeah. So the whole point of the North Star is that it is there.
Yeah.
So.
Yes. Because our axis of the Earth is oriented towards the North Star, right? That's why.
Oh, which is the North Star? Just out of curiosity, what's his name?
See,
You just call it
polar.
Polaris.
Yeah, polar.
It's what?
Yeah,
Polaris.
Polaris.
Polaris. Okay. Got it.
Yeah.
Okay.
Or Dhruva Tara. If
Cool. For the scientific name. Cool. Dhruv Tara or Polaris. All right.
yes.
Yeah. So
And it's going to change in the coming years also. The Polaris will not be it. Next will
What?
be Vega.
Next year, like in
Yes,
2021?
our next pole star is going to be. No. In coming years.
Kitna? Acha. Matlab-
yeah.
Okay. Because
There-
the Earth's axis is shifting or what?
Yeah. It shifts.
Okay.
It precession takes over place.
26,000 after every 26,000 years or something.
Oh, wow.
Yeah.
So
Thus, the pole star changes. So next is we have Vega on the
Vega
line
is-
coming up.
wow, it's like a planetary upcoming. Next up, we
Coming
have
soon.
Vega. AMD Vega.
Oh shit.
Oh, dude. Okay, cool. That is Vega is brighter than Polaris. Okay, will the sun
Yes, it
destroy
is.
our Earth as it is growing with time? Oh God. I don't think so. I
Chandrasekhar limit. No, it will not.
I thought more than the Earth, sun destroying the Earth. I thought the bigger danger was the sun dying out, and then the Earth getting destroyed by itself.
Yeah.
That is a bigger fear. I
Yes,
thought.
that is the bigger danger.
Yeah. So we want the sun to become, yeah, it'll become a dwarf, exactly. That is
White
Yeah.
dwarf.
dwarf. No, I mean, what is a dead star called?
White dwarf. Specifically,
Yeah.
specifically the sun will become, our sun will become a white dwarf.
Okay. All right.
Yeah.
Cool. Back. Where were we?
Okay.
North Star.
Kepler's
No.
third.
Kepler's third law.
Kepler orbit.
Yeah.
So in the
Kepler
third-
orbit तो अलग ही है. तू confuse मत कर मुझे.
Are you talking about Kuiper belt or something?
और is that the Kuiper belt?
No,
No,
Kepler.
वो ऐसे ही बोल रहा है.
Okay.
No.
यार, don't. I'm just learning this stuff. Okay. The third law. Can you get back to the third law
Yeah.
and show
okay.
it? Yeah.
Wait, hold on. Oh my god.
Don't stop sharing it. Keep it open. Yeah, keep it open.
Okay. So the third law
Yeah.
is that there you go.
No. You'll have to do that other thing. Make it change the view.
Okay.
Yeah.
Just say.
Yes. And
Alright.
don't change it.
Okay.
Yeah.
Noted.
Yes.
So the squares of the sidereal period
Mm-hmm.
of the planets are directly proportional to the cubes of their mean distance. So from the sun. So now this talks about what we talked about retrograde motion. This kind of explains it properly,
Mm-hmm.
because now let's say the mean distance from the sun of a planet,
Yeah.
we'll take that, and the sidereal period as in its rotation around its own axis.
Right.
And we measure that to
So
get
mean distance from the sun is throughout that elliptical orbit. तो सारा distance
Yes.
लेके उसका mean ले लिया.
yeah,
Yes.
है
you
ना?
take the mean, yeah.
Okay. Cool.
And
Got it.
yeah, so it's just basically saying ki the squares of the sidereal periods
Okay.
of the planet. It's directly proportional to that.
Okay.
So there is a relation between the time period or the
Hmm.
sidereal period and your distance. It just
So
explains
we
the
are basically talking of rotation and revolution का connection.
in a way. Yeah.
मतलब sidereal period is
yes.
the way the planet. Hey, तो chair हिला मत, ठीक है? That is like an extremely like you're killing a cat. Yeah, don't move the chair. And secondly, so when your planet is rotating, that is what the sidereal period will refer to, right?
Yeah. Like it's a sidereal day, but then there's a sidereal period in the orbit as well. So
Depending on where you are in that revolution. Okay.
yeah. So
Got it.
it's just the relation between that, and
Got
it
it.
helps us understand the retrograde motion.
Got it. Okay, cool. Understood.
Yeah.
Lovely.
All right. So that's
Shall
the
I-
Only one thing about this over here is we make one big assumption which lets us say that these are the laws set by Kepler.
Yeah.
The assumption is that the force law goes by 1 by r square, where r is the distance between two objects.
वापस बोल.
The force law, so the gravitational force between two celestial objects
Okay.
Yeah.
acts is proportional to 1 by r square, where r is the distance between them.
Yeah. Okay. Got it.
This is a basic assumption we take over here, because if this assumption is not taken, then Newton's law don't they are not true, and thus the concept of general relativity comes into action.
एक second.
And
एक second. Who was first? Like Kepler was born before. Like Kepler came up with his laws before Newton, right?
Yeah.
yes,
Yeah. Okay. Cool. So then somewhere he did assume Newton's laws, and so his
Newton-
theories did hold up true even after Newton's laws, right?
So
Okay.
Yes,
Newton's
absolutely.
laws are based
But-
to the
Yeah. Tell me, Atharva.
so but if we deviate from the 1 by r square force thing,
Yeah.
then it does not fall. So we say if it follows 1 by r square,
Mhm.
then we say that the orbit closes in itself.
Yeah, I think that this is technical because I think I'll need to see it written,
Yes.
or like somebody said, we need to have a fundamental fundamental physics talk first before
Yeah.
going into this, because we want to make things simple, as simple as we can. So yeah, ठीक है, I think
Yeah. So this monk has a comment that this has nothing to do with GR, but yes, that was actually one experimental proof of GR.
okay. Come back.
All right.
Listen. Come back.
Yeah.
Come back. So the three laws of Kepler.
Okay.
What did that do? What did that establish?
That established our understanding of the elliptical orbit first.
Right.
Yeah,
right.
we got that and
Got
we
it.
know that the time is same no matter where you are in the orbit.
Okay.
So those two things were very important.
Yeah.
And after that came Newton. He was just walking around. He was thinking. So तभी Kepler का भी आया था, and he was thinking about how forces of nature act, on a certain object.
Yeah.
And that is the exact time when the
Apple.
apple fell on him.
Yeah.
And that time he thought that the apple was at rest. So why would it fall? Something has made it fall.
Yeah.
And according to Newton, gravity is like a force, where Einstein has a very different concept of gravity itself. So if we think about Newton,
Yeah.
Newton के जो first 3 laws है,
Yeah.
we'll just go through that.
Sure. Yeah, that would help.
Yeah. So it's every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. So basically, if you are in state, unless a force is acted on you, you don't move at all. That's the first law. The second law is the force is equal to the change in momentum per change in time.
Yeah.
For a constant mass, force equals mass times acceleration.
Yeah.
So if you are, there is an experiment for this. You just try and push something with a certain mass and see how far it moves, measure the speed. You can do this at home as well.
Yeah.
So this thing is applicable for like earthly basis
Yeah.
पे जो forces रहते हैं.
Ah.
So this is the second law. And the third law is for every action, there is an equal and opposite reaction.
This is the most famous one.
Yeah. So for this, there is how you walk is based upon this. I don't think while walking, we are like, oh, third
Thinking
law.
of
Yeah.
Yeah.
But it's very inbuilt. So that is what comes to my mind whenever I think about these things, that these things are not new to us. We are already
using them all the time. Even laws of thermodynamics, I keep thinking of how
yes.
it is used in like so much of our everyday lives. Even sometimes I even think of human interactions and how they follow laws of thermodynamics, which is super interesting. But I think
that is, yes, interesting.
Yeah, but that is a talk for another day. But just a random thought, right? Newton was thinking about Kepler's laws, and or sort of like it was in that time, and he was thinking about planets, and an apple falling on his head, and putting something of that magnitude to something of this smaller magnitude, and trying to find a common explanation between those two things, led to this.
Yeah.
Which is very interesting to me, because we like on a very different tangential note, we are so keen on putting things in their different brackets, like saying that okay, this is if you are thinking about planets, why are you talking about fruits, right? But the best things came because somebody was thinking about planets and then thought of fruit and said, why not put them in the same equation?
Exactly.
And
yes,
and this is a great example as to why cross platform thinking is needed, because ultimately everything explains everything if you understand it well enough. So
like you can see the connection between different subjects later on as we go in physics, like even with telescope. Like we'll talk about that if there's an interesting thing.
Cool. All right, lovely. Go on.
All right, so Newton's 3 laws are in place. Now we are trying to understand, like he then came up with this idea that there is a force that is acting on these things and acting on us, that is keeping it all together, and he named it gravity. The formula to measure like the gravitational
wait G m1 m2 upon distance square.
Distance between the two molecules.
yes.
Cool. I know this because of the poem. I don't remember it otherwise, but yeah.
You have to do poem at some point.
Yeah. I'll so the whole idea of that gravity poem was based on this, that how just like two planetary bodies will act on each other, and the way they act on each other depends on the masses and the distance. Similarly, for two people, the interaction is based on their personalities and how close they are or how far they are. That's pretty much it. And something has to be constant. Yeah, totally. So it was sort of like how love and gravity can be explained in the same equation. So that's sort of the concept of the poem. But yeah, anyway.
This could be like
impressed. I'm impressed.
Yeah, and the constant bit, right? Like something has to be constant. If there's no
Yeah.
constant, there's no
What's the
relationship.
constant over here?
That's up to you. Like the relationship has to be constant for this equation to work.
That's
Yeah.
okay.
Okay. Go on. All right. Continue.
This
One
is
sec.
beyond science.
Yeah, I know. So Ashmit has just asked, if the universe is infinite, does the conservation of mass rule even hold? Because something minus infinity is still infinity.
Yeah.
But infinity is just a concept.
Yeah, it's not
We
really
actually cannot.
You cannot minus it.
Yeah, we cannot actually apply operations on it. So basically, it's just a concept in all. In physics, the mathematical part, we do apply some operations on it, but then that's not pretty much justified because physicists have that thing of approximating all they can from the mathematics.
Yeah.
And manipulating it in their way.
Like, so even when we say that Baku's depression is constant. Yeah, this chat is super distracting today.
Oh, I love
Okay,
this.
yeah, okay. I forgot what I was going to say. Just go on to the next slide.
Okay.
Oh, god damn it. Yeah. Go on,
Atharvi, you have
yes,
okay.
you guys have to focus, okay? Like, we can't all three of us get distracted at the same time. Meenal, you're not allowed to look at the chat, okay? I know Atharva is
Okay.
constantly reading it, but you're not allowed to.
Okay. Eyes to the screen. Okay.
Yeah.
So now Newton's law of gravitation.
Yeah.
It helped us with the discovery of Neptune.
Yes. Oh, wait, how?
So I hate the name of the planet.
Yeah.
But okay.
You hate the name of Neptune?
No, Uranus.
Oh.
So
okay then.
इतना पुराना है वो joke.
I know, it's okay, get over it.
yeah, I am immature. Okay. So so now when the planet was moving in its orbit, we noticed that it's acting very weird. It seems like there is another gravitational force that was acting on it, affecting its motion.
Right.
And then we turned the telescope towards that planet and we found Neptune.
So it proved that, yeah.
Yeah.
Yeah, it just explained why Uranus is acting in a weird way.
Yeah.
So because it was under the influence of Neptune's force, gravity also.
Yeah, totally got it.
Yeah.
And Meenal totally didn't ruin it for everyone.
I'm so sorry.
Okay. Nepal today is saying blushes everywhere. Yeah.
Oh my God.
Yeah, that's why Uranus was acting weird. Continue.
So these things, like these basic physical laws that we think are such complex maths, what are we going to do with it?
Yeah.
Now we use Newton laws to fly planes and do a lot of stuff that we are benefiting from right now as a civilization.
Yeah.
So this was a groundbreaking moment for that
Right.
time.
Right.
And it has helped us reach where
It
we
is
are.
so incredible. Like 10 years before that, people were still living their lives.
Yeah.
Just like we are living our lives now. And suddenly somebody thinks of something and the world is different.
Exactly.
I mean, it's as if it really is.
We are in a
as if-
simulation.
I mean, I won't say we are in a simulation. I would say it's as if reality isn't reality. Reality is waiting to be discovered.
Yeah.
Right? So reality changes the more we discover it. Like, it's really crazy. So, I mean, I can totally imagine that the day we understand dark matter and the day we understand how it interacts with everything, it'll just change the way we look at everything around us. It'll change.
Yes, actually.
Yeah, like when I'm lifting this glass, when I'm lifting this bottle, I will see it in a different way. Like I mean, Yeah, okay, this is getting too meta. Sorry.
Yeah, but I have noticed, like, over the period of time, as we go with technology, our perception has changed, and
Yeah,
I don't know, it helps with development quite a lot. So, which is great.
sure.
It,
Yeah, I mean,
uh,
yeah, okay. Uh,
yeah.
back,
Okay.
back.
All right. So
So this is
once
a lot
like
like philosophy, that this is the challenge even in my philosophy streams. So astrophysics is something like that because it can just go into random tangents and then you will end up talking about anything and everything. And yeah, and then your main topic gets yeah.
You never
but
know. Next thing is coming up that uh, all we studied till now is false.
Yeah,
Like
yeah.
possible.
someone might come and disprove this also.
Yeah, but my counter argument to that is that even if that happens, it is important to know what was wrong. So the
Yeah.
argument to that
Yes,
is not
point.
that so there's no point in studying. Like that is not the right thing. The right thing is to know how it changed. So the rate of change of knowledge is important, not the knowledge itself.
That is
So
true.
this was very interesting. Actually, Stephen Hawking did his PhD. Uh, his thesis was in singularity, time singularity, and
Oh,
that everything.
Yeah.
okay.
So after certain after certain time after his thesis, while doing his postdoctoral fellowships and research,
Yeah.
so he disproved his own PhD thesis.
Really?
Yeah. Even
So
like Einstein. Yeah.
Mm.
yeah, even Einstein. So these people were the people who really got that feeling what it is to disprove what we believed
Yeah.
in the past.
Which is the ultimate sign of, I feel that it is the ultimate sign of evolution because then you are giving up your identity, so to speak. It's something you believed in, but now you are
Yes.
letting your logic supersede that evolutionary drive of keeping your identity intact. So if you
Right.
can do that, then that's, yeah. Somebody just said philosophy, mythology, and astrophysics seem so relatable.
I
There you
think
go.
philosophy, so physics and everything, it all starts with philosophy. You start questioning things. That is what philosophy is. You think.
We think, we
So
question, we wonder why.
yeah, and a lot of people who have done a lot of work in physics, they actually were great philosophers.
Yeah.
So it's directly connected.
Yeah, that is true of all fields actually, because the earliest neuroscientists were philosophers.
Oh,
Yeah, like
okay.
Descartes, and also I think, therefore I am. So the idea of that there is a mind
Mhm.
and identity is connected to the mind, that there is a separate thing, that itself came from philosophy. Anyway, like it's very interesting, but
Yeah.
yeah, that's what I
Okay.
said. So Newton's three laws, you were saying.
Yeah, so Newton's three laws helped us with the
Yeah,
discovery of Neptune.
yeah.
Now, here's the thing. Around this time, we started cross-pollinating with other fields as well.
Mm-hmm.
Because now the thing that we used for telescope, the person who made microscopes,
Mm-hmm.
instead of looking up, he decided, oh, well, let's look on the water in my hand. And he realized that, oh, the water is made up of smaller particles of water. And then came another field of
Mm.
another science. And,
Right. So telescopes led to
Condensed matter
microscopes.
physics.
what?
Another branch of physics. Yeah.
Yes. Telescopes. Yeah.
Okay.
Telescopes led to microscopes.
Yeah.
Okay.
And it's like every discovery in any field, be it directly interacts with the other field because we are all made up of atoms at the end of the day. So it
Stardust.
affects, yeah,
We are all stardust.
yeah, I see.
Yeah. I mean, it's cheesy but true. Yeah.
It is true. Yeah, I
Yeah.
mean, there was this one question I saw online somewhere that if uh, nothing can be created nor destroyed, that's the law, right?
Yeah.
So if that's the case, then we are not 20 years old. Our atoms are as old as the age of the universe.
Exactly. That's also a line from the Bhagavad Gita.
Oh, okay.
Yeah. Which is what is interesting because yeah, I have Like I have astrophysics on Friday,
Yeah, but
mental health on Saturday, and Bhagavad Gita on Sunday, and it's been an interesting trip seeing how everything talks the same thing basically, but just in different angles. But yeah, tell me, what are we saying, Atharva?
yeah, it's just that there are many questions upon the Big Bang theory also. Like, did it all start from one particle?
Yeah.
And or is it as Stephen Hawking said that it is everything? It is contract. It will expand. It will contract. It will expand. It will contract.
Yeah.
So there is no definite beginning and there is no definite end.
Can I ask you a very, very random question that I've always been curious about?
Okay.
Yeah, go ahead.
Why is the symbol of infinity like the way it is?
Like how we write it?
Yeah.
Yes.
It came from a culture of a snake, so it showed something with
the snake eating its own
Yeah.
tail.
Oh.
Right.
It's like a loop. Yeah.
So I have always been fascinated by it because since I started thinking about this and what you said about Big Bang, right? So the point of everything collapsing into one thing, into nothingness.
Yeah.
And I feel somehow, I don't know why, I feel that, okay, and it just starts expanding on the other side after that. And then collapses again, and then it expands again. And that also looks like infinity. And it's just a very random trip in my head. But that's how I always thought of infinity. Also because of like the number line, right? So when you write the number line, the 0 in the center and infinity on both sides, and like literally if you just connect that infinity to 0 because nothing is everything and that kind of thing, it again becomes the damn infinity loop. And it's super random. It is absolutely random. But yeah, I always wanted to ask an astrophysicist that what is the meaning behind this?
But yeah, it doesn't have an origin in physics. It seems now.
Yeah.
It has something to do with snakes.
Yeah. So somebody said snake eating its own tail is a circle, and that is like I have seen that loop, like snake eating its own tail. But yeah, I'm not very sure where that infinity sign comes from.
I'll try and look up because I saw that on in a video. It kind of explained infinity origin. So I'll try and look it up.
Maybe it comes
and
from.
send it.
Okay. Meenal, we have to get to the next slide. Yeah, tell me.
Okay. So after Newton, we kind of got an idea of planetary motion. Now we have an entire idea of our solar system.
Right.
Slowly, we started to realize that light that we see is just a small part of what the entire thing is, the electromagnetic spectrum.
The visual spectrum.
Yeah. So we...
Yes. No, not exactly the visual spectrum, but we see only some part of it.
Right. Yeah.
We cannot see most part of it.
Right. So Vibgyor we can see. We can't see infrared or ultraviolet.
Yes.
Yeah.
Right.
Yes.
Oh,
we can't see any of those.
Yeah, that's the one.
This is our visible scale, which is, if you look at it, it's so tiny.
Yeah. Yeah.
So there is another entire, species of light, you can say.
Yeah.
So we started to realize that, and that helped us understand the composition of things, because we realized things interact with light in a different way, and that's why we get the colors. So that helps us explain the composition of that object.
Yeah.
So
yes,
for an example,
we can see such a small part of the universe.
Yeah.
Yes.
Damn.
And we
actually now technically we can see much of the part of the universe because then we have the equipment.
But even there,
naked eye only this much.
Correct. But even there, okay, I get it. But even there, we are converting that into visible spectrum, right? At some point, it has to hit the brain. And the problem is with our retina. like a retina is the rate limiting factor. Like
Yeah.
our retina can only process this particular spectrum, and whatever technology you use, until you upgrade your retina, you can't really see the next bit.
Exactly.
I'm having
It's
so much
Absolutely.
FOMO right now. Like, just imagine, like, if you can increase your spectrum even like 10 raised to 8 to 10 raised to minus 4 तक अगर किया तो
हाँ.
like the world will look so
so
different.
different. Yeah. I think we'll be
So
so annoyed.
this was in the movie, right? Lucy
Ah,
wala.
yeah.
Oh
She
yeah,
can
yeah,
see
yeah.
the
Lucy,
light.
yeah. Correct.
Yeah, she can see many wavelengths.
Many wavelengths.
Yeah.
Okay.
It would be
So one
annoying.
proof of these wavelengths actually exist is you must be knowing this, Ed. So basically, our body emits IR radiation and then so we measure the temperature during fever
Yeah, that is
using those
infrared.
guns
Yeah,
absorbing IR radiation.
correct.
Yeah. So we know they exist. So it's not just theoretical speculations.
Yeah,
We know they exist.
correct. Yeah. Like the amount of heat we radiate, I mean, all that has some color, but then we can't see it.
Yeah.
Yeah,
Yes.
continue.
And I think with the visible light, so there's once this thing again, the understanding the properties of light has helped us understand a lot of things in different fields as well. So there's this astrophysicist who was working on something related to galaxies and the chemical composition, and he was trying the light ka thing with different elements in the periodic table, and he realized that the atoms, like different elements ke atoms resonate with the magnetic field in a different way. So let's say helium ka ek way mein karega, and
React with light.
not light, the magnetic field,
Okay.
not the light.
Okay.
Yeah.
Okay.
But just he was trying to figure out the chemical composition. He realized, since we know all of this, that there is.
Oh, okay.
Yeah.
Got it. So that's how you know, like, the chemical compositions of different.
Yeah.
Yeah. Okay.
So that thing helped us. There is another physics like alag sa concept hai wo with.
Understood.
Now that thing, a biologist read that, and he was like, "Oh wow, we are made up of atoms. What if we had a machine which can help us understand tissues ka structure? If like tissues will resonate differently as well because they have a different chemical composition."
Correct.
And then that's how we came up with MRI machine.
Right.
Someone who was studying galaxies.
Yeah. That the same technology can be used across any field.
Yes, absolutely.
So the concept of MRI machine is the way hydrogen atoms react with magnetic waves, which is okay. Wow.
Yeah.
Okay. Got it. Lovely.
So it's just understanding that.
But this is not that surprising because at the center everything is physics. So
yeah. Fair enough. Like if you look at physics as the way you understand the universe, then obviously by definition, that knowledge will be used across all fields, because
yes, so we can extrapolate that for all fields.
Yeah. So when Shoto had come on, when we talked about philosophy, we had talked about the purity of sciences. So from the most pure on the left to the most impure on the right, we went from mathematics to physics to chemistry, and then it went on to biology. And within biology, as you go on to the right, it becomes more and more impure. So the word impure meaning it becomes more subjective.
Okay.
So the more pure it is, the more useful it is going to be across all spectrums.
Right.
So when we go to say a subject like social psychology, it is very subjective. So the lessons of social psychology may not be applicable to physics, but the lessons of physics will be applicable to social psychology, because the more pure it is, the more applicable it is for everything. So that sort of thing.
I mean,
yeah.
I think astrophysics has a very like the modern astrophysics
Yeah.
has its own relation with politics as well. Like I was talking to a friend of mine, and it's another topic we can discuss it when it gets
What?
to
No,
that.
no, no.
But I'm
Just
very
give the
interested
gist.
in
Just give
this.
the
Yeah,
gist.
yeah. What is this?
Yes, absolutely.
How does
So
yeah.
it's not like you apply physics laws on a politician. It's not that, but you
Okay.
use the benefits of astrophysics for political purposes. Like I said with Columbus, right?
Yeah, yeah.
So the Hubble telescope that we sent in space, the most powerful telescope there is
Yeah.
as of now. Uh, it there was like they created a model of that, which was actually used by U.S. military.
Uh-huh.
That was the first thing that we used, which was facing the Earth. And when we noticed its precision, that is when we were like, oh, we can use it to look at space as well. And then we
Right.
sent Hubble telescope.
Right.
So a lot of connections between military and astrophysics.
Understood. Understood. So cool.
Yeah,
Okay. The Hubble telescope was when? When did they send it?
2000.
Oh,
Yes, sir.
This is
2000?
pretty recent.
Really?
So-
Oh, I thought it was like 1980s, 90s or something. Okay.
No, no, it's very recent. It's very recent.
Oh, okay.
Wait,
Cool, cool, cool.
I have.
Much more research than.
Lovely. All right.
And it ended its term when? I don't exactly remember.
It's still there in the space, so.
Of course.
Huh, yes, but yeah.
Yeah, tell me. What next?
So Hubble, okay, so we got across Newton, now we know the solar system. We'll just look a little at solar system
Mhm.
as what do we know about it. Where is solar system? Okay, here we go. So this is Earth,
Yes.
very pretty
Hi, Earth.
blue. This is where we live,
Yes.
and you can see yourself maybe. No, you can't. Okay. This is another picture of Earth that people believe is true.
Oh God. It's like a,
So-
yeah. Cool.
So this
I
is
wonder
the-
how would it be like to fall off this edge.
Yeah. So I heard a lot of, I mean, I actually went and read about flat earthers, and there is a lot of theory as to why is it like this, and they believe that it's surrounded by water on all sides, and
Yeah.
it's got a base, and yeah. Anyway, I think this stream would crash if I talk about flat earthers anymore. So
flat earthers, honestly, I don't care.
okay, next.
All right. So let's go to sun.
Okay.
The first father, mother, whatever you call it.
Yeah.
That's the sun. And that dot, that's Earth in comparison to sun.
Oh wow, that's such a lovely photo. Okay.
So so we have sun, then we have Mercury.
Can you show
And
Uranus,
look
please?
at-
No, Neptune.
Oh, no, so first we have Mercury,
Yeah.
Venus, Earth,
Yeah,
Mars, Jupiter, Saturn, Uranus, Neptune, not Pluto.
not Pluto. Not
Not
Pluto,
Pluto.
guys. Justice for Pluto was going on in the chat sometime. Yeah.
Yeah. well,
Okay, this
that's
is
what
Mercury.
happened. So this is Mercury.
Looks a lot like
And
the
it-
moon.
It does, right? It's smaller than that, actually, I guess.
Sure. Okay.
Yes.
And it, so like he said, a third, huh? So when Einstein came up with his general theory of relativity, we noticed that the Mercury actually moves pretty fast in its orbit around the sun.
Hmm.
So it's like 47 kilometers per second. It's the
Okay.
speed,
Okay.
which is, yeah.
Which is quite fast.
So this is,
Yeah, and it violates the Newton's laws
yeah.
Oh.
because the force law is not proportional to 1/r² in its case.
Oh. So how does? Okay. Tell me.
Yeah, that's for another day. Fundamental चीजें लगेंगी उसके लिए, but still. Yeah, so it does not violate. It does not follow the 1/r² rule, and therefore it violates that rule, and therefore the thing we have established as Kepler's laws actually start descending, and we don't actually get that. So that was actually the first experimental proof of GR.
Yeah.
that we
Okay.
observed.
Like for a long time, people were like Newton के laws
Are
उस side work कर रहा है, but आगे क्यों Mercury में क्यों नहीं work
क्यों
कर रहा
नहीं
है?
कर रहा है? Okay,
Yeah.
because the closer you get to a strong source of gravity, the rules start changing,
Break. Yeah.
Yes.
so
Like
to
you
speak.
move faster.
You
Yes.
move faster. Right.
Hmm.
Okay. We
And
need to talk about general relativity, by the way. I think yeah, we should
yeah.
probably do that, just out of my
Okay.
curiosity and everybody's curiosity. Yeah.
All right. So this is Venus.
Is that why people
And
use it as a description for people, like he has mercurial personality? I don't know why people use
I have
it
never
that.
heard
I
this.
have never
No,
heard
I've
this.
heard of that mercurial personality. Like, either he's very temperamental, like he's very hot-headed. I think, Lavina, is that what you mean?
Oh,
Yeah, I've heard of
so
this.
okay. Mercury has extreme climates. It's like very cold and hot at the same time, even if it's closer to the sun because it doesn't have an atmosphere.
Okay, so everything
So
is just all right.
yeah. So I don't know. Maybe just
Maybe, yeah.
referencing to that.
So yeah,
Yeah.
Ashwin is saying we need to learn special relativity first. Okay.
Yeah.
Yeah, we can talk about
Obviously,
relativity.
yes.
We can talk about relativity in general. Like that would be such a cool topic to talk about. Just relativity. It can go anywhere.
We would have to take that talk pretty slowly
Yeah.
because
Yeah.
There's a lot of
grasping it is a task in itself.
There's yeah. Cool. Okay. Back to the
Okay.
slide.
So this is Venus,
Hmm.
and we recently saw the news of phosphine in its atmosphere.
Yeah. Correct.
So
Showing that it could have signs of life. Yeah.
yeah, it's like
Yeah.
the thing that living organisms release. So maybe they're like, oh, ho sakta hai. We don't
Okay.
know for sure,
Yeah.
but maybe.
Yeah.
So
So that is my
Venus-
problem with looking for signs of life, because we have to first define life.
Yeah,
Like life as we understand it, right? So that's the problem.
Our
Because
perception of life.
correct. So because when we are looking for life, we are looking for chemicals, but life is not defined by chemicals, because we are completely filled with chemicals, but so is a rock.
yeah,
The only difference is consciousness. And how do you look for consciousness through a telescope? What are the markers of consciousness?
So I mean,
It's I
I
don't know.
don't know.
Yeah.
Okay,
Yeah.
I was reading a book on astrobiology,
Yeah.
and they mentioned that methane is a great indicator for that, because as living organisms, we release methane in a large amount. So I don't know if it's not a measure for consciousness for sure,
Yeah.
but our existence has its own
Yes.
Sure.
after this.
But
And
methane.
when we say that the planet is habitable or can sustain life, we don't say it for us humans, obviously.
Yeah.
We start with the
Yeah.
microbes first.
With the microbes, right? But
Yeah.
there are methane clouds and methane pools, and which one? Titan. Who had methane
Yeah,
lakes?
Titan has that.
Yeah, Titan has
Right.
methane pools.
Right. So my point is that chemistry can exist because chemistry came before biology. So we are looking for chemistry and looking for signs of biology, but then yeah, okay.
Yeah.
Again, talk
I
for a different day.
understand
But
your-
yeah, because consciousness is a different. We don't have markers for consciousness. That's the problem. And we equate life with consciousness. We don't equate life with chemistry. So
Right.
yeah.
I think when they talk about life, it's just like एक कीड़ा भी मिल जाए तो काफी है.
Of course, because that is also conscious.
Not even Kida.
Yeah.
Whether or not a tardy bear can survive over there.
Yeah, that's
So
the tardy. Yeah.
might be no.
Yeah.
Yeah.
Yeah, the tardy bear is. Yeah. Yeah. Okay, continue.
Okay. So Venus, then we have Earth, and then there is Mars. Maybe our future home. Maybe not.
SpaceX would
Elon
win.
Musk's planet.
Yes. He's just going back home, yeah. Let him go.
Oh yeah, I've seen so many memes on that.
Correct.
Okay, so this is Mars. Pretty like
Yeah.
I don't want to get into the properties of these planets and everything because it's like astronomy ka bahut basic wala cheez.
Sure. Yeah, no problem.
Heading towards
Because we do
astrophysics.
have to kind of head towards wrapping up in some time because
Yeah.
astrophysics will go on. So whatever we have left, we can always do justice to it in another stream. So don't worry. There
Okay.
is, yeah. So
Yeah, absolutely.
yeah. So let's just cover the things that we thought we will talk about and then go into depth later.
Of those.
I'll
things,
interrupt you less from now. Sorry about that.
Oh, it's okay. I was
Yeah,
just, okay.
Tell me.
So there's Mars, then
Yeah.
Jupiter. This is my favorite picture of Jupiter.
Hmm.
It's an actual picture taken by the Juno spacecraft,
Okay.
and that's from. It's like uska pole hai yahan pe, so you can't see it. That's the entire picture
Oh,
of Jupiter,
lovely.
taken by.
Red spot.
And
Yeah, the red
this
spot.
is famous
Yeah.
for.
So
Yeah.
basically, this Jupiter is a gas giant which was initially closer to the sun,
Yeah.
Yeah.
and so it traced back itself over there, reaching an equilibrium position. Maybe equilibrium relative to us right now,
Mhm.
Correct.
as like basically referring to the time scale.
Yeah.
It might follow another path in the future.
Lovely. So that red spot is a huge cloud, right?
It's a storm.
It's
Yeah.
a storm. It's a storm
It's a storm.
that's just been going on forever.
Yeah.
Damn, that's such a cool thought. Okay.
So, like, if you can go on NASA's site, there's like multiple videos of people just observing how the red spot moves, and
Okay.
it's so fascinating. I think everyone should go and check that out.
Yeah. We can just keep that as a screensaver. Like, just let it. Okay. Cool. Go on.
Alright, so this is Jupiter,
Yeah.
and then one of the most beautiful planets in our solar system,
Stars.
Saturn.
Oh wow, what a picture.
Saturn.
Is this also an actual picture?
Yeah, it's like
Cassini,
Damn.
yes,
this.
by Cassini.
It was right in front of the sun, so it just took a picture.
Wow, what a picture.
Ima-
Yeah.
Like the technology that we have come up with, that we have sent literal robots into space using Newton's laws, okay, and understanding Kepler's laws and everything. We're just roaming around in space taking pictures of planets. It's
What a
very
picture.
fascinating.
Like,
Yeah,
Christ.
absolutely.
can I ask? Sorry, I know I said I won't interrupt, but how
You
do
go
they
ahead.
send the picture back?
Well, there is
Radio
data.
waves? Through radio
Yeah,
waves?
they don't take a JPEG image, obviously.
Yeah.
They take so they have a telescope which has a CCD attached to it. It is a camera, basically.
Okay.
A telescopic camera. So it takes in. So basically, it has a plate on which photons fall.
Ah.
It records the intensity and then converts that
Into
array kind of
electricity.
thing of intensities
Yeah.
into something, and then that is transferred through obviously our
Through radio waves.
at different wavelengths through radio packets. Yeah, radio
Okay.
packets, and then we receive them and frame that into an image.
Yeah, sort of
Yeah.
like how the brain does. In fact, exactly like how the brain
Ah,
does.
yes.
Yeah.
Exactly how.
Someone
Amazing.
had
It's
said
like
that-
it's like a giant planetary brain with all the robots acting as retinas and sending it back to us, which is the cortex. Oh my god. This is so cool. All right, continue.
I had read somewhere that us understand
You should make a field of this completely, astroneurology.
Astroneurology. I know. So, like every camera ever does, no, like, is that no? So every camera does what? It stores it right there, right? Yeah, but okay, I get it. Like, of course, like,
Yeah.
it is about photons and recording it, obviously. Yeah,
It's similar with the satellite imaging, right?
correct. Yeah.
Technology,
So
with
what?
GPS or everything.
What got me interested was how you are not forming the image right there.
Yeah.
You are only collecting the data. Just like the image isn't formed in the retina, the image is formed way back in your occipital cortex. Just like that, the camera there doesn't form the image. The image is formed back on Earth
Yeah.
Yeah.
from what you're
So it
telling me.
forms something of matrices. Those
Yeah.
matrices are combined, and each
Exactly.
matrice is assigned a pixel, or
Yeah.
each pixel is assigned a matrix,
Yeah.
and then that image is reconstructed.
Yeah. Exactly like how the occipital cortex
Exactly
works.
how the brain does it.
Correct. All right. Continue. Last
So-
interruption, I swear.
Yeah, it's okay. I mean,
Yeah.
what you said about how it's similar to what the brain does,
Yeah.
I read somewhere that trying to understand the universe is like, we are trying to understand our own brain,
Yeah.
but on a larger scale, like the phenomena are similar or something.
Right.
Like,
Yeah.
that's just the statement. Okay. So this is Saturn.
Saturn, Cassini. All right.
Okay. And there's Uranus.
This is Uranus.
So
Sure.
So it's like it is horizontal.
Yeah.
It moves this way, right? So its axis is like this. No,
Yeah.
ours is like this, perpendicular.
all other planets have a vertical axis.
Yeah.
So what's special
Yes.
about this?
Or a tilted one.
They just
It just
Yeah.
is. It's just
it's
weird.
like
No, there is some reason, but I am unaware of it right
Okay.
now.
Cool.
I think there was a speculation that something hit it and then it toppled over and horizontal ho gaya.
What?
Why?
I
It's a
can
gas
just-
giant. How
I
can
can
it?
just
Wait,
imagine.
it's a gas giant. How can it?
I can just imagine
Exactly.
astrophysicists
It's not
sitting
even
around.
solid.
And somebody must be like,
It's
"अरे
not
कुछ
even
तो
solid.
कुछ तो आके ठोका होगा अरे लिख दे like the day before submit करना है लिख दे."
It is not even solid.
Yeah.
It's
Yeah, exactly.
gas giant.
So how can it?
I don't know. It was just a theory, and I was like, okay. I mean, if that's what you say,
Cool,
it doesn't
man.
affect my daily life.
Please give something solid. Yeah, and then that's.
So this is our Neptune.
Hey, hi Neptune.
No, this is not Neptune. Oh my god, this is Neptune.
Okay. Hey, dude.
This is Neptune.
You just, dude. Okay. Yeah, this is Neptune.
Your favorite.
I love it, man. It's so blue. Yeah.
That sounds sad.
It's
but
just
okay.
cool.
Yeah.
Yeah. So this is Neptune, and then for just to do Pluto some justice,
Yes.
here is Pluto.
Yeah.
Has a poisonous heart. Like
I-
this is
Hi
Dwarf
Pluto, bye
planet.
Pluto. Such a sad thing, yeah. Okay.
so yeah. This is our solar system, and if you look at the distance of these things, you can just imagine how far we have gone
Yeah.
in distance, which is very
Mm.
fascinating for people who just live on Earth and fight
Mm.
about stupid things. But yeah.
Right.
And again, so our sun
So
is
you missed one part over here.
the
There are
asteroid.
lots of asteroids in the Mars-Jupiter belt and Trans-Neptunian belt,
Right.
Yeah.
The Kuiper belt.
Kuiper belt, or
Kuiper
something.
belt. Okay.
Kuiper belt.
Yeah.
I mean, I think that, oh yeah, I had like taken out a page, एक web page खोल के रखा था of the live feed of our solar system.
Okay.
Like,
Show.
मेरा screen हटा गया. एक minute,
अच्छा, ठीक है. Don't worry.
hold on.
So, all of this stuff we have known for the last what?
A few years, like ये 90s, 80s में अभी.
19s, 80s. Okay, cool.
Yeah. Like
So,
we have known till Mars, Saturn, tak it was like visible from Earth, but after that we got to know recently.
somebody's asked about Oort's cloud.
Oh yeah, it's like
Oort
after-
cloud, yes. It's after the Kuiper belt, there is the Oort cloud.
Okay. So, what is the Oort's cloud? Where is it?
So
After the
it-
Kuiper belt.
After the cloud.
Alright.
Okay.
So it's basically solar system here. Now we attract a lot of asteroids, stray
Yeah.
objects from
Yeah.
the space, right?
Yeah.
So it's just filled with those things because of our gravity, and
Gravity.
it's like a safe net around us.
Right. So they're just constantly circling around.
Yeah.
Wow.
And also, just to clarify, the sun is not stationary at this point. We have realized.
Yeah.
we know-
Sun is also moving.
Yeah. So
Right.
the orbit.
Yes, absolutely.
It's like sun hai, and then Earth uske saath aise aise ja raha hai.
Yeah.
It's like
So
a dance.
I read about that, right? Like, so the way, the speed at which the Earth is rotating versus revolving versus the whole solar system is moving, and the
Yeah.
whole galaxy is also moving. But at
Yeah.
some point of time, you have to ask, in relation to what?
In relation to,
Yes.
at least as of now, the galaxy and everything.
So basically, there is always a galaxy cluster.
Right.
In most cases, there is a galaxy cluster. So
Okay.
I'm not saying that every galaxy is a part of a cluster. There can be isolated galaxies, but what generally is found is a galaxy cluster. So basically, this galaxy cluster has a centered galaxy, which is the dominant one.
Oh wow! Like the sun
And
for the
every
solar
other galaxy
system.
is under the influence of that. Yeah, and and the point over here, the particles and everything is, it is important to appreciate the existence of intercluster medium,
Okay.
intracluster medium,
So
ICM, what we call
every
it. That.
galaxy, when it grows up, thinks that I am the center of the galaxy cluster, and then some
just-
Copernicus comes and says,
Yes,
"Ki,
absolutely.
nahi." Oh
Yes.
damn! I love it.
And this entire cluster formation comes out of the dark matter particles.
अच्छा,
Yeah.
I mean,
Alas.
you just skipped like 3 classes ahead. भाई तो
Exactly.
धीरे धीरे बोलना मतलब. I know you're excited, but आराम से. You have to build up. So this is, I won't blame you. So even when I was teaching neuroscience, this was the problem, that you need to know, you have a lot of knowledge for sure, but the whole idea of teaching something new is you need to know how to build up to it. You can teach anything in this universe, anything you can teach, but you have to build up to it, right?
Yeah.
So then,
Yes, absolutely.
yeah, that's the challenge, even for both the listener and the teacher. Okay, like, how do you build up to it? So 1 second, galaxy.
The listener has the patience of building up.
Both ways, absolutely.
Both ways. Yeah.
So wait, coming back.
So
so
this
yeah.
is
Okay, perfect.
our solar system live feed.
ये तो
as
एकदम
of
मस्त
this-
सर्कल में बना है, लेकिन एक्चुअली सर्कल में है नहीं.
Circle nahi hai. Yeah. This is like, okay. So the asteroid belt, it's between like Mars and Jupiter,
Right.
and they have added this
Serious.
as well because it's like
Yeah.
it could dwarf planet consider kar de use.
What?
Borderline dwarf planet and an asteroid. It's the largest asteroid.
Oh, okay. It's the largest asteroid. Okay.
Yeah.
Got it.
And then obviously then there are things
Yeah.
beyond Pluto as well. Like it could be. We just unka orbit itna bada hai ki we
Bada
never
hai.
do.
Okay, like Eris, I can see Eris on the corner. Wait,
Yeah.
there's something called make.
Yes.
What?
I have
I bet the pronunciation is not like that, but still,
Maki, what is it?
it can be that some
Amazing.
Japanese name.
Yeah.
I have no idea what that is.
Okay.
Yeah.
Cool. Now we know how the
These are just
earliest
dwarf planets and
human beings
asteroids.
felt when they looked up at the sun. I have no idea what that is. Make up a name. Okay, make. Cool. Continue.
You're so lazy with the name.
Maki, Rajni.
They were even lazy with the constellations.
Yeah. I think so. Now enough about planets.
Yeah, cool.
We are done with solar system. We have seen our family.
Yes.
And now let's look more into the sky. There are stars and constellations, and now we start seeing some cloudy things in the sky, which are then we classify them as nebulas.
Nebulae.
So for that, it's for that, like उसके लिए star का evolution का process समझाना पड़ेगा. So I'm just stating it as of now, and then we can discuss it आराम से. So
what is planet X? Yeah.
They are saying कि Pluto के पीछे planet है.
Oh, okay, cool. We'll see. पढ़ लेता हूँ.
I don't know.
हाँ.
So there is this theory कि there is a mini grape-sized black hole beyond Pluto का cheese because the orbit is a bit messed up again. So it was like,
Oh,
Black hole? No, not. Huh.
yeah, it's just a theory. It's not a real thing.
Huh.
You don't know.
okay.
Hypothesis.
Like just to
Hypothesis.
explain the that. Okay. Just
Yeah,
like
like
we
making
use Neptune to explain Uranus.
it. Yeah.
Okay, got it. Got it. All right.
So
Hmm.
yeah,
So
that's
1 second.
Hmm.
How are we going to take this conversation forward?
Yeah.
And how, because I don't want to rush on any one topic, but we have finished till planets
Yeah.
and we have to take a call,
Yes.
right? Because we can aram se do a separate stream and discuss stars, nebulae,
Yeah.
unless you think that we can sort of wrap up in 10 minutes, but then again,
No,
Yeah.
we can't. We can't.
we can't,
We're
right?
just gonna talk about how
Yeah, we have to do the entire stellar structure still.
Yeah.
Then we can only reach till the star evolution, and then after that, nebula and supernova, black hole, GR.
Oh my
Everything.
god.
Dark
Okay.
matter, dark
Black
energy.
hole. Okay. So I wanted to go to black hole, but I think we will take time to get there. Right?
Yeah. So
Cool.
this
Patience
is
is the key.
Patience is the key.
Yeah.
We came a long way. We went from earliest humans looking at the sky to time, calendar, understanding seasons. They went into the sea. They came up with how to calculate directions, compasses. Then we went out. We Kepler's laws. The sun is not at the center. The loop thing that the Mars did. Then planets. The Newton's laws. We found out about all the axis of the planets, all the 9 planets, and we have reached till there.
Yes.
Yeah. We haven't
Okay.
like
Yes.
talked about rockets because
We haven't
it's-
talked about rockets.
but that's again a different thing.
It's a
so
different thing.
That's a technological that can be done anytime.
Wow, this topic is endless.
yeah.
So
because-
basically, till
Yeah.
now, we have come from 10,000 BC to
Yeah.
2020 AD. Or 2000 AD.
Yeah, 2000 AD we have reached.
2080. Yeah.
Yeah.
No.
So that was fast.
We knew about that was very fast for a 2-hour live stream to cover. No, but 2000 AD ke pehle hi they knew about black holes, right?
We had
Yes, but
speculated them.
I mean-
speculations were made, hypotheses were there.
So this is not entire like exact time scale. This is
Yeah.
the basic time scale that you'll need to understand future topics.
Yeah.
Yes.
So, do you think it would do more justice to talk about nebulae, evolution of stars, and black holes
Yeah.
in a separate live stream?
Yeah.
Yeah?
Yeah, absolutely.
Because once you start, like once you crossed our safe zone of our solar system and enter into the dark space, we should step out having had dinner.
Yeah.
Because we don't know when we are coming back. So I think that
Okay.
makes sense. I think let's do that. It's already 11:50. I don't know if you've looked at the sky, since we are seeing time through the sky.
Yeah.
But I think we should do that. I think we can talk about stars up till black holes in the next one. We have to talk about gravitational waves.
We have to. Yeah.
I need to know about that.
Yes.
And
really
I guess we
want-
will need 2 more sessions in this way.
because
Because
after that
now
we'll talk.
the point is
Yeah.
No, the point is now we have come till 2000. So now from 2000 to 2020, it's a very slow process. There are a lot many things to absorb.
Yeah, things picked up, I think, recently.
Yeah.
There's been a lot of new stuff. All right, chat. Are you with us? What's your scene? What do you say? Let's take. Okay, Atharva Ashar has said Astrophysics Part 2 with the same awesome people. Absolutely. Oh, I loved this conversation. This was super fun. Gaurav Moite Part 2, dude, for sure. For anyone interested in the planets of the solar system, there's a great TV series by Brian Cox called The Planet.
Yeah.
Okay, we'll watch that.
Yes,
Akshay,
absolutely. That's a good one.
yeah.
Cosmos, so you should watch
The
it.
Cosmos I've seen. Wait, I haven't
The
seen the
Cosmos.
Carl Sagan one. I saw the Neil deGrasse Tyson one.
Yeah, I mean both are good.
Both are good, yeah.
Yeah.
Akshay Mohindru is a member now. Welcome, Akshay. That's so cool. There's a beautiful saying: "The universe through humans and astrophysics, astronomy is seeing and understanding itself." Yeah, sure.
Yeah.
That's very true.
Absolutely.
Okay. So what we'll do is, we will talk about stars, evolution, and black hole in the next one, and
Yeah.
then we will talk about dark matter.
Yeah.
Oh
That will be
God,
an interesting.
there is too much. There is too much. I don't know when we are going to fit it, but we are going to do it in an urgent basis. I want to get to dark matter also.
All right.
All right.
Yes, absolutely.
How
Yeah.
much time do we have?
Yes.
What?
Yes, somebody put up Amrut Skanda something.
Yeah.
Discuss how exoplanets are discovered, why starlight dip. Yeah, we will do that also.
Yes.
I have a
Yes.
nice. I had given a nice presentation on it in our club also. Yes.
Okay. Lovely. Dark
Um,
matter matters. Yes, Captain America. I think that's very true.
That should be the name of the video.
Dark matter matters. Yeah. We'll call it that. Sure.
Yeah.
The next
Okay.
one we'll call going into a black hole or something like that.
Yeah.
And that's what we will do. Let's just take some chat. So Meenal, you have a lot of admirers. I'm just saying, once and for all.
Thank you.
Yeah. Okay. Now that we've got that out of the way, there is a very interesting. This was a very interesting stream. Utkarsh, thank you so much. This was super fun. Check Discord channel picture before, and so I just made a channel on Discord called Learning Astrophysics, so you can go and
Oh, great.
discuss
Yeah.
there. Yeah,
That's
so
nice.
we can yeah, you guys can join. You can yeah, I think your Aminal is already there. I think Atharva, I don't know if you are.
I'm also there.
Perfect. So then
I am also there.
I'll
Yes.
make you moderators. You can answer all the questions that people have, and
Absolutely.
so
That would be great. That would be really great.
yeah, talk about, please explain origin of Big Bang. That would,
Yeah.
wow, that would
The
also be a great
end
topic.
of dark matter वाला जो भी series का end is gonna be the origin and fate of the universe. That's it.
Yes.
Damn, what a teaser, yeah. Like that is super fun. Wouldn't grape-sized black holes? Yeah, so there's a lot of grapes going on in the chat. I think you're talking about black holes, and yeah, when all of it condenses, like all the mass condenses into a grape, like.
Mhm.
Okay. Yeah, I want to talk about asteroid mining also.
Oh yeah, we should.
Yeah. There's too much. Yeah, there's too much to talk about. Chalega. We'll do it. We'll take it one at a time. Yeah.
Also, I want to do the pale
Yes.
blue dot thing.
Oh yes. Go. Yes. Meenal wanted to do it. Yes.
I am dying
Yes,
to
yes.
do
You're
it.
dying to do it.
Coming
We are going to end it with the pale blue dot. All right. Awesome.
All right. Wait, hold on. I want to see everyone.
Yeah. Hitvik, please don't delete the streams. No, we are not deleting the stream. This is going to be on it. All right.
All right.
Meenal, over to you.
Yeah. Okay. I am just looking for that thing. Okay.
Uh-huh.
So the picture you're seeing on the screen is a picture taken by Voyager 1. And so it was in 1990 when the operators of the Voyager 1, they just told the Voyager to look back at the solar system once before it left it permanently.
Yeah.
And the dot that you see on the screen, as Athar might be pointing it, I can't see it,
Yes.
is Earth. And Carl Sagan wrote something very profound on that. And I just want to share that with you. And so it starts like, wait, hold on. Yeah. Wait, my PPT is not opening. All right. Okay. So look at the dot. Consider again that dot. That's there. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forger, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor, and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust suspended in a sunbeam. The earth is a very small stage in a vast cosmic arena. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Our posturings, our imagined self importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. Our obscurity in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we have ever known.
This is so
रुला
beautiful.
दिया.
रुला दिया यार. Carl Sagan and Meenal, thank you both for doing that. That was amazing.
Yeah.
Yeah, I read about this first in when he released Cosmos. I'd seen the documentary on it, and they had this whole speech on it. But yeah, every time you hear this, it
It,
hits you.
it does.
Yeah, absolutely.
It just reminds us that how lucky we are to even be here in the first place. And once we go further into space, like we go back to Big Bang, we'll realize the possibilities of us survive, like being here alive, are so rare. And yeah, it's just amazing. Yeah.
That we are here, and that three life organisms got together on a live stream to talk about this. What are the odds of this happening?
Exactly.
This was amazing, guys. Thank you so much to both of you. You guys are awesome.
Thank you for having us. Thank you.
Yeah.
Thank you for the opportunity to get to the people.
No, this was really nice. Chat, I think we are going to end with that. I can't think of a better way to talk about end the first live stream on astrophysics. We are definitely coming back for a part 2. Bagul, I need to ask Atharva, is it your birthday?
No. Those were just my friends.
Yeah. Cool. So I just wanted to confirm. With that.
Also, just one last thing.
Yeah.
It's Space Week. This is Space Week going on right now, like celebrating space. So this was a really good time for doing the stream.
Lovely.
Yeah, that was it came out
Space
nice.
Week.
It came out.
So cool. Wow. Okay, I hadn't planned for that, but yeah, the whole universe conspires.
I didn't even know it.
The whole universe conspires when you're doing something fun. Okay. Lovely. Happy Space Week, everyone. I shall see you all. I'll see you all in the next stream.
Yep.
Bye.
Bye-bye.
Happy Space Week.